we know about climate change because of satellites, right? Like, okay. Because satellites that pollute. No. All right. Never mind. Never mind. Anyway. All right. Yeah, my bad. No, Alex, no need to apologize. I misunderstood. It's all good. Point still stands. Can we just have something that's fun, please? I totally agree with no engine manufacturer is going to make V10s anymore. Yeah. Yeah. No, I know. All right. Let's see. Here. I want the ablator video. Here we go. That's enough time. All right. I'll be back in a second.
There was a time when a meteor flashing through the sky struck man with a deep sense of wonder. Even today, man's reaction to a meteoric display is likely to jam the switchboards with reports of imminent invasion from space. But as heirs to the knowledge, disciplines, and apparatus of the scientific revolution, we are familiar with, and at least partially understand, the meteoric phenomena. A meteoroid, traveling in space outside our atmosphere, remains unseen by man, for the molecules in space are so dispersed that collision with them causes no visible effect. If its trajectory traverses the Earth's atmosphere, it becomes a meteor. Here it begins to collide with more molecules. These collisions become more and more frequent as the meteor descends into the denser air of lower altitudes, causing it to decelerate. Each collision converts some of the energy of motion into heat energy, and the heat continues to increase until the meteor itself becomes incandescent, scribing its visible path through the night sky. Destroyed in the atmosphere by this heating, most meteors present no danger to man. Now and then, one is large enough to survive its passage through the atmosphere to Earth. It is then called a meteorite, and some are very large indeed. Dr. Peter Parameter became interested in meteors early in his career, and once wrote a paper titled,
"A thermokinetic description of bodies in passage through a plastic medium of nonlinear density at random velocities and angles, which could be just about summed up with this equation."
With this equation, his fellow scientists and designers are able to explain the effects of atmospheric penetration on differing bodies, those with different ballistic coefficients, at various velocities and angles. For example, if two bodies of different weights enter the Earth's atmosphere with the same velocity and entry angle, both the heavy body and the light one will begin to heat up at the same time. But impacts of air molecules slow the light body sooner. This deceleration of the light body occurs at higher altitudes, while the heavier, more energetic body penetrates deeper before it reaches peak deceleration. The total amount of heat generated by the lighter one is less than that generated by the heavy one, whose larger mass gives it greater kinetic energy. Two identical bodies with the same velocity entering the atmosphere at different angles also will decelerate at different rates. The steeper angle causes a more rapid encounter with the dense air, resulting in more abrupt deceleration. The total heat generated will be the same for both bodies, but peak heating will be less for the shallow entry. With identical meteors entering at the same angle but with different velocities, the faster meteor, under heavier bombardment by air molecules, will have greater deceleration, generating more heat and at a higher rate. But Dr. Parameter is no longer merely an observer interested in understanding the phenomena of meteors. A meteor is just an aimless traveler in space. Doc finds himself now involved in designs with a purpose and an aim. A missile has a target, and a spacecraft has a destination, a journey's end. To these, Doc applies his knowledge. He knows natural phenomena, both of aimless meteor and aimed missile. He knows that as they traverse the atmosphere, they heat up. If the heating or deceleration of a vehicle is excessive, the mission is threatened. Man cannot change the laws of nature, so he must use his knowledge to work within those laws. Doc Parameter knows that the two natural enemies to successful atmospheric penetration are deceleration and heat. He can fight these enemies on two possible fronts. First, on the design front, by modifying the vehicle's shape and size relative to its weight. In other words, its ballistic coefficient. And second, on the program front, by altering the vehicle's trajectory, its velocity, its attitude, and its angle of entry into the Earth's atmosphere. Dr. Parameter is now ready to use his technology to plan a successful re-entry for an ICBM warhead. He knows that of the two natural enemies, deceleration and heat, high deceleration is not a problem with a warhead, but too much heat could destroy it. He first surveys the project on the program front. He knows that the re-entry velocities and angles are essentially set by the mission. But to reduce heat load, the velocity of the re-entry vehicle could theoretically be reduced by firing a retro rocket. On investigation, he finds that in order to decrease re-entry velocities sufficiently by this method, a retro thrust system would be required weighing many times the weight of the warhead. This method is out. He next considers the possibility of changing the re-entry angle. He knows that a shallow angle will lessen the peak heat load by stretching the heating over a longer period of time. But the total heat generated will be the same either way, and the vehicle could absorb even more heat during this longer re-entry. Furthermore, a shallow re-entry angle has other serious drawbacks. First, a shallow angle impairs accuracy by deflection in the atmosphere. Second, it affords more time for enemy interception. A steep re-entry improves the missile's chances of avoiding interception and of reaching its target with minimum atmospheric deflection. In this case, altering the program is not the answer to the heat problem. Dr. Parameter must attack the problem of heat on the design front. Logic would seem to indicate that fast travel requires a streamlined shape to slice its way through the air. At subsonic velocities, this is true, but at supersonic speeds, the moving vehicle displaces air molecules which bounce off, forming a shock wave. As speed increases, the shock wave becomes more severe, and heating increases. An ICBM will have a free-fall re-entry speed in excess of 23,000 feet per second. At this speed, the heat of molecular collision and friction, shearing of air molecules, is concentrated in a narrow zone along the surface of a streamlined vehicle. The heat generated may cause the temperature to exceed 15,000 degrees Fahrenheit. To combat this terrific heat, Dr. Parameter designs instead a re-entry vehicle with a blunt frontal area. The blunt shape creates its shock wave somewhat ahead of the vehicle. This occurs because the atmospheric molecules colliding with its frontal surface bounce back and intercept others coming in setting up a kind of picket line in advance of the warhead. The peak heat is generated in this area away from the surface of the vehicle. Although the blunt shape decreases the peak heating of the warhead to half that of the streamlined shape, it will still heat up to 7,000 degrees Fahrenheit, much too hot for unprotected warhead structures. To further reduce heating, Dr. Parameter must find other techniques in addition to the blunt shape. His first solution is the heat sink. Use the blunt design and add a mass of heat-conducting metal large enough to absorb most of the heat generated during re-entry without melting before impact. It works, but he is not yet satisfied. The weight of the heat sink displaces more than 1/4 of the payload. Furthermore, the blunt design slows the missile, keeping it in the atmosphere a longer time, making it less accurate and easier to intercept. For the greatest accuracy and shortest time in the atmosphere, Doc knows that the streamlined shape is the best, but the heat sink cannot absorb and distribute the sudden extreme heat generated during the re-entry of a streamlined vehicle. Doc reasons,
If the heat cannot be absorbed, why not eject it as fast as it's generated?
the answer is ablation.
Ablation! Coat the frontal surface of the streamlined missile with layers of ablative material composed of fibers, resins, and ceramics.
This ablative coating protects the missile from the extreme heat in several ways. It is a poor heat conductor. Its surface gradually melts away, taking heat with it, and its vapor forms a thin insulating layer, deflecting some of the heat from the surface. The ablative principle combats the heat problem effectively and permits steeper re-entry angles while adding a minimum of weight. The streamlined missile, with its increased speed, affords the least possibility of interception and the greatest accuracy. It does produce a huge deceleration factor approaching 150 Gs. Fortunately, this poses no threat to a warhead. But for manned or other recovery missions, the G-load is a most important factor. For manned re-entry, this force should be held below 10 Gs. A shallow re-entry angle of about 1 to 5 degrees is the simple answer. The shallower the angle, the less the G-load. But this will be sustained over a longer period of time. This means a longer time at high speed through the friction of the atmosphere. Let's take a moment to see why this is not desirable. Dr. Parameter?
Thank you. Gentlemen, we have here a kettle of water. Heathcliff, we can use you in this experiment.
Oh boy, an experiment.
Thank you, sir. Now, if we may have another kettle of water and your stand-in. Thank you. Now we'll proceed with the experiment.
Experiment?
We'll add the same amount of fuel under each kettle, but alter the form of the fuel under one kettle to make it burn faster. We ignite both at the same time and compare the results. Splendid. I'd like to point out that the fast-burning fuel, although reaching its intensity quickly, exhausted itself quickly. The heat absorbed was negligible. The slow-burning fuel, on the other hand, gradually increases in intensity. It will generate the same total heat load, but over a longer period of time, and you'll notice more heat is absorbed. Wow! Thank you, Heathcliff.
Thank you, Dr. Parameter. So although the peak heat generated in the shallow re-entry is less, the capsule is in the heating regime for a longer time, and without the utmost protection would absorb an intolerable amount of heat. For manned re-entry, Dr. Parameter overcomes the deceleration enemy through program with the shallow angle, but he must combat heat on the design front. A blunt shape to cause a detached shock wave, a picket line against heat, and ablative materials for additional heat control. The doc is confident his new design will fulfill the requirements. Now to try it out. He wants low peak deceleration, so the shallow re-entry path is mandatory. This brings him down safely, if a little off target. To achieve some control and accuracy as well as safety, Dr. Parameter has been working on other design concepts, particularly shapes that produce lift. He knows that a ballistic missile is designed and programmed to hit a particular point on the Earth's surface. A manned ballistic vehicle with the same objective is much less accurate due to its design and long, shallow penetration. But a lifting vehicle, which is capable of descending at a still more shallow angle and with an extremely low deceleration rate, is able to change direction. This control gives it wide selectivity of landing sites within a large footprint area. For the shortest range within the footprint, the vehicle is pulled up into a maximum lift attitude at re-entry. This induces maximum drag, causing a steeper, more abrupt descent. For the longest possible range, the vehicle must assume the attitude of maximum lift-over-drag ratio. This footprint, huge at first, shrinks gradually as the vehicle descends. Dr. Parameter, while considering the advantages of lifting vehicles, is also aware of their drawbacks. First, the lifting structure itself imposes weight penalties, which compete with the all-important matter of payload. Then, lifting vehicles may also spend up to 20 minutes in the heat regime, and being more streamlined, they require a still more complex heat protection system, competing still further with payload. Dr. Parameter, with his associates, has studied the strategy of atmospheric penetration. He knows its natural enemies, deceleration and heat, and has met them on the two fronts of program and design. He has accomplished important objectives. For the intercontinental ballistic missile, the objectives are rapid atmospheric penetration and accuracy. The warhead's natural enemy is sudden, intense heat. Its program...
All right, guys. The presser is going to start. If you want to watch the end of this later, we can watch the end of this later. It's no problem. But we need to go over here. Oh, okay. Sellers agreed on our $1 back for the house sale to use on repairs. Not a lot, $1, but enough for the joists and more. Pretty dang exciting. Congratulations, Niv. More F1 later? Yeah, I think so. Yeah, that's one of my favorite videos, guys, the atmospheric penetration one. I'm just gonna go get a bottle of water real quick. I just wanted to make sure I'm here for this. I'll be right back, 1 second. All right. They're trying on Saturday, Rogue. Before, after. Cool. 2 p.m. Saturday. What do you mean, Cairo? What spurred that conversation? Alex, sorry, I misunderstood what you were saying. You shouldn't apologize to me. I should apologize to you. Yeah, no, I was like, because everybody was talking about engines, so I assumed that that's what you were talking about. I'm like, no! I just want something that doesn't suck. And spaceflight is pretty much that. But yeah. Alright, I got all the links. Thanks, Tech. No biggie. Needed to get it out. Yeah, I usually do that off stream, though, you know. If you're wondering what the keys are, it's just the keys to the shop. I always lock the shop when I go down to the house. It's a good way. It's a good ways away. Love the streams. All the best. Thanks, Tech. Oh, did my audio cut or did the music go? Seed. How's your commute to work been? Very peaceful, Bandit. Yeah, the shop's back a little ways in the woods, man. Like, it's surrounded by trees. Like, there's the house, there's the lawn, and then there's woods, and then the garage, so. I got a nice peaceful walk through the woods. Dude, you know what? Critters. Critters, all kinds of stuff. Not just like squirrels and chipmunks like in the city. There's like bunnies and frogs and crickets, like all manner of stuff that I'm just not used to seeing. Dude, I haven't seen a frog in years. I saw one hopping around in the shop. I'm like, and I let him out. And I'm like, is that a frog? Discord. That's terrible. Yeah, but that's also pretty funny. Is the audio low? Any moose? No. I haven't seen a raccoon, no. I get bunnies, deer, and turkeys. I got turkeys. I saw a turkey, and I'm like, that's a turkey. All right. They were back by the garage, Bill.
Less than 2 days away from our next opportunity.
All right, here we go.
To launch the Space Launch System rocket and Orion spacecraft on a flight test beyond the moon. Welcome to NASA's status briefing for Artemis 1. I'm Rachel Kraft with NASA's Office of Communications. The mission management team met earlier today to review the status of preparations for the mission. Launch of the uncrewed Artemis 1 flight test is currently targeted for Saturday, September 3rd. At 2:17 p.m. with a 2-hour launch window. Joining us here at Kennedy Space Center in Florida, we have several guests who will give us an update on the preparations and overall status. We have Mike Serafin, Artemis 1 mission manager. John Honeycutt.
That's John Honeycutt right there. I'm sorry, I'm shutting up.
John Blevins, SLS chief engineer. Charlie Blackwell Thompson, Artemis launch director. And Melody Levin, weather officer with the Space Launch Delta 45th. We'll start with a few comments from our guests, and then we'll take questions. For those of you joining on the phone, you can press #1 to be entered into to the question queue. And I will also note we do want to keep our briefing to an hour today to give our guests some much-needed rest. So with that, Mike, let's start with you.
Okay. Well, good afternoon, and thank you for continuing to follow the Artemis 1 mission. If you recall, 2 days ago we had a scrub following the August 29th launch attempt, and we needed a little bit of time to assess our risk posture headed into a subsequent launch attempt, and we reviewed that today as a mission management team. A little bit of time helped us work through all of the information that we gathered from the first launch attempt. And we worked through a number of issues, and we discussed our risk acceptance rationale for a subsequent launch attempt. If you require from our prior attempt, we had the tail service mast umbilical leak. We had a hydrogen leak in the tail service mast umbilical. Coming out of the last launch attempt, we met and agreed to do some work out at the launch pad. That work has been completed. We had an issue with the core stage intertank vent valve. That has checked out, and we do not consider that to be an issue. We also had an issue confirming that we were able to thermally condition all of the core stage engines within the required temperature limits as part of what we call the engine bleed. And we worked through that today. And then near the end of the launch attempt, we saw some cracks in the foam on the thermal protection system on the core stage at the intertank flange, and we reviewed that issue today. There was some incremental risk acceptance. As the mission management team, it is our role to review risk acceptance and then the flight readiness rationale. And then we also have requirements change authority following the agency flight readiness review, and we review any changes from the previously accepted risk baseline that we had at the agency FRR. And we did that today. Only 2 of those items required some incremental risk acceptance, and that was the thermal conditioning of the engines associated with the engine bleed, and then the core stage thermal protection system, the crack that we saw, specifically what is termed crack number 2 at the intertank flange, just due to the potential for debris transport, and then contact with the booster SEP motor. It's a low likelihood occurrence, but it is something that we considered an acceptable risk. So we reviewed our risk acceptance rationale and our overall risk posture, and we are setting up for a launch attempt on September the 3rd, Saturday, and we're comfortable with our flight rationale and risk acceptance there. In addition to that, we did have some late analysis come in associated with an off-nominal performance scenario where if we have, and this, we're not planning on this, but should we have a underspeed at the completion of the translunar injection maneuver, it shows that our trajectory would put us into what we call an eclipse violation, which is a power production issue for the Orion spacecraft. So as a result of that, it is specific to the September 4th launch opportunity. We agreed to take that off the plate. So we are, again, proceeding into our Saturday launch attempt. We're comfortable with our risk posture. That said, there's no guarantee that we're going to get off on Saturday, but we're going to try. And the technical teams have put in a tremendous amount of work in a very short amount of time to get us here. And thanks to the work and the effort that they've put in. So with that, I'll pass it back to you, Rachel.
Okay. John Honeycutt.
Yeah, good afternoon. It's a pleasure to be here. I think when I talked day before yesterday, I mentioned that we had a lot of data to go look at. And so, we had come out of the first launch attempt. We were unsuccessful on gathering the data that we wanted to gather for that, what we call the bleed kickstart. The team has done a tremendous amount of work starting right after the launch, even up until this morning and to the noon hour, leading us into the MMT meeting. What I would tell you is they just did an outstanding job nailing it flat, and we'll share some more of those technical details. But at a high level, we have convinced ourselves without a shadow of a doubt that we have good quality liquid hydrogen going through the engines, and there's no fuzz on that. We've also, through the course of analyzing the data, looked at 5 additional measurements that we can look at to assure ourselves that we are getting that quality data, and that's on the engine. That's on the engine side, and then on the core stage side, we were able to go back and verify that the core stage is providing the amount of hydrogen and the quality of hydrogen to all 4 engines. And so I'll turn it, I say Dr. Blevins and his technical team just did an outstanding job working through that, and we'll share some of those details, I'm sure, as we get to the questions.
Okay. John Blevins?
Yeah, I'll just add that we do have an outstanding team, and they did look at the data. You know, we had some things we were looking for in launch attempt 1 that were combined with what we expected to do in a wet dress, and so we had some sensors that didn't tell us what we thought we would do, and we did the right thing by standing down with that uncertainty on Monday. But we have confirmed that we did have good flow through those engines. We know we can chill those engines. We're ready to proceed that way to launch. You know, the SLS team does a lot of other things, and as Mike mentioned, we brought some other things. We inspect the vehicle. We brought the concerns we had over any TPS as minimal as they are forward, and we've analyzed, and the teams are ready to support launch attempts on Saturday.
Okay, thank you. Charlie?
Well, good evening, everyone. It's great to be back here talking to you about our preparations for Launch Countdown. I think we met and talked just a couple days ago, and when we had our last press conference on Tuesday, we had finished up our safing and securing out at the pad, and we were getting ready to send the access stand out so that we could begin work on the LH2 TSMU purge can, where we detected that leak during our tanking operations. That work is all behind us. We finished up the work. We were able to find what we believe is the source of the leak and correct that. And that purge can's been put back together. We have leak tested it at ambient conditions and also done some flow-through tests with our HAZGAS system, and we believe we're in a good configuration for the next loading attempt. We also went back based on what we saw during the, and working with John's team, looking at any countdown enhancements that we might need to make. We have made a couple of changes as we prepare for this next loading operation. And really what that means is that we're going to start our LH2 chill down, the facility side of the chill down, right around the same time that we begin our LOX chill down. So that'll allow us to begin that kickstart bleed a little bit earlier, and we'll pick up that kickstart because I know I'll probably get a question about when that is, and we'll start that just about 8 o'clock on Saturday morning. So we've made a couple of changes to the countdown. Our teams have been very busy in Firing Room 3 running against the model. We finished up 2 days of that testing to make sure that we had our procedures all down and ready to go. It didn't require any software changes. It was just the procedures that we go through, but we also want to make sure that we have those ready to go. And everything right now is on track. We have remained in launch countdown. I know some folks think that, you know, launch countdown, it starts 2 days prior. Sometimes when we're in a scrub, we stay in launch countdown, and that's what we have done this particular time. We've been in originally in a 96-hour scrub. Of course, we added a day on to go do this purge can work. And we've also taken replenishment of both LOX and hydrogen. Both tanks are topped off, which is great. And so we are on track to support our 0557 tanking operations on Saturday morning, setting us up, as Mike said, for that 217 window open.
Okay, thank you. And Melody?
All right, good evening, everyone. You got to me a little faster than I thought. Anyway, as I was walking over here, I noticed a lot of anvils kind of streaming in from the west coast, and I even saw some mammatus clouds up there. So let's go ahead and look at satellite and see what's going on. So basically, right now, we actually do have offshore flow, meaning flow out of the west coast, or generally a westerly flow. You can see a lot of thunderstorms popping up across the interior portion of the state at this point in time. They are spreading east, but I actually just looked at radar. You're looking at infrared satellite here. Radar is different. But in general, the showers themselves are staying across the interior portion, not getting close to the Cape at this point in time, but you can see a lot of anvil from a lot of those showers and thunderstorms. But anyway, this pattern that we have today is actually going to be transitioning into more of an onshore flow regime as we get into tomorrow, and that is mainly due to the fact that we'll have a ridge that's building across the state of Florida. And what it will do is deliver easterly flow, and that easterly flow will stay intact for several days. So that's actually normally pretty good news for us. It keeps our lightning risk a little bit lower than what we would normally see on a typical afternoon in the summer for Florida. So anyway, we'll move on to the primary launch window forecast. And with that, you can see I have a 60% go for the launch window when it opens up in the early afternoon on Saturday. Winds pretty steady out of the east at 8 to 12 knots, which if you want to convert to miles per hour, that is 9 to 13 miles per hour. I know there's some weather nerds out there that might pick up on that. But anyway, temperature pretty warm, as you can expect. It is Florida, 86 degrees. Our main concerns for the primary launch window will be the cumulus cloud rule and the surface electric field rule. So then we'll go ahead and skip ahead to the backup window, which is actually Monday, and that actually improves. The weather improves a little bit to 70%, and that's mainly due to the fact that the launch window is a little bit later into the afternoon time frames, and with that we would expect the east coast sea breeze to be positioned farther across the interior portion of the state, giving us a lot of sinking air behind it in general. So basically the weather looks good. I wouldn't be shocked if there are periods where we are technically red for weather, but the bottom line is that I don't expect weather to be a showstopper for either launch window. So with that, I'll go ahead and pass it back.
Okay, thanks very much. We will take some questions now. We'll take some questions in the room and on the phone line. A reminder to reporters to please limit to one question, and if you will state your name, affiliation,
We'll
and
see how
who
long
you're
that
addressing your
lasts.
question, that would be a big help. So we'll start with Marcia Dunn.
Marcia Dunn, Associated Press for either of the Johns. It sounds like a bad sensor then. Is that your best hunch? And could it be anything else besides a bad sensor for the Monday's situation? And what would happen to an engine if the fuel wasn't cold enough at ignition? Would it just crack? Would it burst? Something else? Okay.
Yeah, I can start and then I'll let Dr. Blevins add in. Yes, we do think we know we had a bad sensor. That was our challenge early in the week, where we could not make the physics of the system line up to what we were seeing with that one sensor. So since then, we've had time to go back and look at the data and compare many sources of data and do some independent analysis that confirmed it's a bad sensor and we're getting good quality propellant through the engine. And so your question on the engine is there's a lot of things that we do on the engine to monitor the engine to make sure that it's operating the way we want to see it through operational flight instrumentation, as well as we have what we call an advanced health monitoring system that is on each engine that is designed primarily to look at vibrations and that sort of thing on the engine and pick those up as an early warning. And so, John, I'll let you add more there.
Yeah, let me follow up. The problem in part with the sensor is during ranges of temperature, it gave us the right slopes. It seemed to work fine, and then it did not give us an indication that we expected at the very cold temperature. So it really was an interesting signal, and that's part of the pause. It didn't just fail off scale or anything. So, but John is right. It is conclusive that sensor was not a witness for what we were looking for. It's absolutely true. On the engine side, we do have advanced health monitoring. The reason we chill the engines for numerous reasons, but the primary one is for the high-pressure turbopump bearing. And that high-pressure turbopump bearing doesn't have to be all the way as cold as the liquid, but it's got to be cold. And if we know the liquid is going through, then we know it's about that temperature, and that gives us margin to that problem. And if it starts up and it's not cold, then it can skid. Ultimately, that causes excess wear on startup. That would manifest potentially as a shutdown during flight. It would be a red line. It wouldn't be, I'm not sure how you characterized it, but it wouldn't be an uncontained failure generally for that particular issue. I mean, but as John said, we have advanced health monitoring on the engines for a reason. These are high performance, really the highest horsepower per mass device that has ever been built. And so we need that health monitoring, and there's numerous things that we're looking for when we do that. So, but the sensor was bad, and in this case, what we're protecting against is a bearing skidding on startup and causing excessive wear.
Bill Harwood.
Yeah, hi, Bill Harwood, CBS. One question, Rachel, but it's got 2 or 3 parts, so sorry about that. No, it's pretty straightforward. What gets masked? I'm assuming you have to mask out the suspect sensor, but where in the software do you tell it this is okay to start an engine, this is not okay to start the engine, and where would that occur? Is that before terminal count, or would it be at ALS transition? How does that work? And what, I guess another way of asking that question is, what tells the computers that the engines are at the right temperature to start? I mean, how is it knowing it's at that 420 degrees John mentioned yesterday to be able to press ahead with start?
I'll go ahead and take this one. So first of all, the protection for the engine is not, this sensor was never intended to be used as an LCC or for this purpose. It is not part of ALS. It is not part of the startup protection. Ultimately, the reason we use this sensor is to get an initial indication of cold fluid. We did combine this launch attempt 1 with an objective we did not achieve in wet dress, and that's why we had more verification work to do. We were going to do that verification early in launch attempt 1. This sensor failure prevented that verification, and that's why we had to go to subsequent measurements. And we were able to achieve that really only because we were in these conditions for a long time with fully tanked and flow through the engines. If we wouldn't have done that, we wouldn't be able to verify all that we could to verify that it was liquid and that it was a bad sensor. But ultimately, the protection for the engine that's in ALS are temperatures and pressures, but they're not the ones that we use for a long chill of the engine. If you reflect on the last answer, it was that we're trying to chill the engine to get a bearing cold that we don't measure. And so that's buried inside of part of the engine. And so we count on a certain amount of mass flow for a certain amount of time in order to ensure that that bearing is cold. We did that during shuttle. We've done that during the entire program that used formerly the Space Shuttle main engines and now the RS-25s. And so that verification is a process verification we just didn't achieve in WDR4. That's why we were using this measurement. It's not part of ALS, so there's no masking in the computer software. All the normal protections are in place. We added an LCC. I asked Charlie to add an LCC for this verification because we didn't receive it in WDR4. That's ultimately what this measurement is. It was never really intended for the purpose we ended up using it for.
So tips during chill down wouldn't play into whether or not to start an engine. There
are other temperatures that verify the liquid at the interface to the turbopumps that were ready to go, and other skin temps. This one was used as a witness for the bearing chilling for a certain amount of time and is not strictly relevant to the startup conditions.
Yeah, and John mentioned something that I want to pile on a little bit on. It's he talked about what we learned in the shuttle, and we did this engine conditioning through process control. And so I think I'd gotten a question about the difference between shuttle and SLS earlier in the week, and we had those recirculation pumps on the shuttle where we took that we took the heat out of the engine by circulating the hydrogen through the engine and carrying it back into the hydrogen tank to boil off, and so we're in the same situation here where we want to use our process control to assure ourselves that we're delivering the propellant quality that we need to the engines. And so, we had that process control on shuttle for these engines. It worked fine. we validated that process control when we were at Stennis for the green run, and our plan was on Monday to validate that for this vehicle with the configuration that we have on the launch pad. I talked to you relative to the differences between Stennis early in the week and the launch and what we have out at the launch pad. All those are still in the direction of goodness. We've got a bigger vent line on the ground side. It's insulated, which means we could flow more through that line. And our bleed system and our relief system is bigger than we had at Stennis. So all that still holds true.
Okay, we'll do stick with the front row. Here with Stephen.
Stephen Young with Spaceflight Now for Charlie. We're so used to seeing views inside the LCC, and on Monday we saw nothing, and your team was working so hard, and there's so much interest in this mission. I'm wondering, why are we not seeing any video in our isolated feeds or on NASA TV from inside the firing room?
Yeah, there will be views from the firing room that will be mixed in with all of the coverage.
Okay, Marcia Smith.
Marcia Smith, spacepolicyonline.com. I'm curious what the other limiting factors are and how many times you can attempt to launch. You have the flight termination system battery that you have to come back to the VAB to swap that out. Are there other limiting factors? How many times can you tank and detank? You know, how many times can you give this a shot?
Yeah, I'll take a first crack at that one. Physics is one of the key limiting factors associated with the sun. The Earth and the Moon position relative to what this initial configuration of the Space Launch System rocket is capable of with the interim cryo propulsion stage. So we lose our ability to fly into a lunar intercept after September the 6th. And that's one of the key limiters. There's also the flight termination system. It's essentially a reliability check in the interest of public safety. And I don't know, Charlie, if you have any others to add on that, but those are kind of the key drivers at this point.
So you can tank and detank an infinite number of times?
Not infinitely. We track those, and we're a ways away from those limits.
Okay, Stephen, and then we'll go to Irene.
Stephen Clark, Spaceflight Now. Just so I understand, on WDR4 back on the 20th of June, ALS cut the countdown at 29 seconds for when it realized the engines were not thermally conditioned for flight. If the engines are not at the proper temperature on Monday, this sensor notwithstanding, ALS would still cut the count. There's no risk of igniting an engine at the wrong temperature. Is that a proper understanding?
Yeah, that's correct. I want to make sure you understand. ALS is checking the temperature, pressure, and many other parameters at that moment. The whole point of the sensor that we use, which we would have just verified process, as John talked about, is to get time at temperature for that one part, and now we've confirmed that through other means. So the engine will not start unless we hit the engine start box. ALS will shut it down.
And are you actually masking that?
No,
sensor?
we are not masking anything in ALS. No, we're not masking what we're measuring. That sensor is an engineering sensor for engineering data. It is not a flight. It's not OFI. It's not a flight instrument.
Okay, and we'll go to the second row to Irene Klotz, and then we'll take a few from the phone.
Thanks. Irene Klotz with Aviation Week, maybe for whomever. Do you think that starting the kickstart procedure early will give you a reading that the sensor is now working, even though it's just an engineering sensor? And do you think that just because they're engineering sensors and not the fidelity that you have elsewhere in the system and in the ALS software, that that's why the other engines were not quite cold enough either?
Yeah, let me let me take that. No matter what that sensor does, I've learned a lot about the flow process, which is what you do a WDR for, and we ended up, unfortunately, doing that somewhat on Monday. And we stayed at condition for a while, and we flowed not just through all 4 engines, but even through just the one that we were slightly more concerned about. And so whatever that sensor does, I have lots of supporting evidence that's much higher fidelity from the engine itself on that chill process. Starting it earlier certainly makes me happy because I'll get an indication earlier in the day that the engine's looking good. And time at temperature, as I told you, is what achieves a good bearing temperature, so we'll do that. As far as the other 3 temperatures, they're extremely consistent with saturated liquid temperatures. And, I think a lot of people have talked about those temperatures being off. In the case of Stennis, we had those 3 temperatures, and we defined what saturation was by what we measured at Stennis because we knew we had saturated liquid in the core stage green run. And in this case, if you're able to go back and take a look at that data, you'll see that they were at saturation temperature. So they may have been 1 to 2 degrees Rankine away from what we expected or what we saw as a witness prior 18 months earlier at the core stage green run, but they are consistent with saturated liquid. So there's no question that the engines receive saturated liquid. And quite honestly, normally, you would have done a WDR and you would have a few weeks to review that data, and there wouldn't have been that comment about it not reading on all these sensors and that kind of thing. We would have used all the evidence, and we've compressed that time, and we've got very good evidence, as John has said, that there's no question that we had liquid flow through that engine. And now we have other witnesses, and we'll use the data we have available when we do the kickstart procedure, and we've got lots of data in order to confirm that we start that liquid flow process.
Thanks. Okay, and we'll go to the phone and take a few questions from there. We'll start with Michael Sheets of CNBC.
Hi, everybody. I believe my question is for Mike Serafin, but it's most specific to the amount of risk analysis you're looking at for a Saturday launch attempt. Based on the data that you've seen so far, given that this is supposed to be a full demonstration of the system, if there were astronauts flying on board this mission, would you still be launching based on the parameters that you're looking at, or are the risk analysis that you're considering different than if you were, launching the Artemis II mission?
Yeah, Michael, that's not an easy question to answer because again, Artemis I is the first test flight in a series of increasingly complex missions, and the next mission is intentionally, Artemis II is intentionally our crewed flight test. So Artemis I, we are buying down the risk associated with crewed flight on the next mission, specifically reentry of the vehicle at lunar reentry conditions. In order to get there, we have to set up those initial conditions using the performance of the rocket by getting it to the lunar reentry conditions. The rocket has to deliver us to the point of translunar ejection. We want to shake down the spacecraft through flying out through the Van Allen radiation belts, the orbital debris field, and operate it in the deep space environment. Those are all things that we have to do with crew on board on the very next mission. And we know that there's risk involved with this first mission, but in terms of the incremental risks that we dispositioned today at the mission management team, it was a marginal increase in risk, and we are clearly ready to fly on Saturday with an understanding of what that risk is. We would have a very similar discussion on Artemis II if we had any of the conditions that we're seeing on this flight, and we would make an appropriate decision. So it's a hard question to answer because it presumes that we are successful on Artemis I, and there's a non-zero chance that we will find something on Artemis I that will cause us to reassess our risk posture on a crewed flight.
We'll stick with questions on the phone, and we'll take our next question from Lauren Grush with Bloomberg.
Hi, thank you for taking my question. So, correct me if I'm wrong, but it sounds like the sensor that caused all the drama is separate from the critical sensors and other data inputs the engine computers use to know that they're in the right launch configuration. So why do you need that sensor at all? And was there an option during the countdown to cross-check against those engine sensors and inputs, or are you saying that there wasn't enough time to do that? Thanks.
Yeah, that's a good question. We do not need this sensor for flight. The sensor was set up to be engineering information for a chill down confirmation process. And what we're trying to do is make sure that we have cold liquid for a certain amount of time, just like we did on shuttle, to infer that the rest of the hardware is cold. And that's what we're trying to do, is just chill that down. That's why we call it the chill process. This sensor is not used for that time. Those sensors were deadheaded that you would use at that particular time and were not appropriate references for us. In fact, that's not what we're using to confirm that we had liquid flow through the engine per se. And so, you know, that it was an engineering analysis that where we combined the wet dress with the launch attempt, and we were unable to confirm that chill process, and that's what stopped us.
Yeah, and John, let me add a point here. We had a plan going into the August 29th launch attempt, and it used these sensors to help confirm the proper thermal conditioning of the engines. We had trained that plan, and then we ran into other issues. We ran into a leak at the tail service mast umbilical, and then we had a vent valve that was not operating properly. So we were off the script in terms of the normal tanking operation, and the team did a fantastic job working through the managing of a hazardous condition. And one of the worst things that you can do when you find yourself in a hazardous condition is just go even further off script and to deviate and get into an operation that you're not prepared or trained for. So the team did absolutely the right thing on the 29th, and they knocked off the operation, and they knocked off the test, and they got us into a safe configuration, and then they spent the last couple of days reviewing the data, and that was absolutely the right thing to go do. 2020 hindsight, these particular sensors, we know aren't the best cue to work off of, and you know, we've reassessed the plan, and we have a great plan moving forward. We understand the risk posture associated with getting the engines thermally conditioned, and the team was asked today very specifically, are you ready to go load the vehicle with this earlier tanking and earlier bleed flow operation? And the answer was absolutely yes. So I don't know, Charlie, if you have anything to add to that one.
No, I think you covered it.
Okay. Our next question is from Eric Berger with Ars Technica.
Hi, thanks for doing this. That was great, Mike. Thank you. I'd like to take another crack at a question I think Marcia was trying to ask earlier. Based upon comments we've heard during earlier briefings, it does seem like there's been some mild concern about the shelf life of the stacked Artemis 1 rocket. And I guess what I'd like to understand is, are there wear and tear issues that you've mentioned on the rocket? You know, Marcia asked how many cycles were left in the core stage propellant tanks, and, you know, just wondering, like, are you feeling some urgency to get this rocket off in the next month or two, or are you good in the configuration you're in now for quite a while? Thank you.
We're good in the configuration we're in for a while. As I alluded to earlier, you know, I'm not going to give you an exact number, but I know we're well into the high double digits on additional tank cycles. As far as worrying about things with the rocket sitting on the pad, there are probably more little things like we see cracks in TPS and that sort of thing that we have to go analyze to clear. You know, but the big thing we want to avoid is rollbacks to the VAB. Those are the things that Dr. Blevins has told me will put more stress on the vehicle than anything else. Now, that said, we've still got rolls left in the vehicle, but we want to watch that and manage it. Do you want to add anything, John?
I'll say we track all life-limited items. We watch that very closely. I don't have any concern on the pressure cycles of the tank, just as you said, John. We have numerous cycles left, and that's to a good margin of safety. I do like to protect the rolls because they're complicated, and they affect every part of the rocket, but we have plenty of rolls left at this time, too.
Okay, one more on the phone, and then we'll come back in the room. Joey Roulette with Reuters.
Hey, thanks. My question was asked.
We'll come back in here in the room. We'll go there in the second row, Jeff Faust.
Jeff Faust, Space News. For Mike Seraphin, quick question. If we do launch on Saturday, what is the length of the mission? And do you have to do any changes to the mission plan if it's shorter than 42 days?
Yeah, Jeff, that's a great question. I will confirm it here, but I believe it's a 37-day mission with the splashdown on October the 11th. In terms of changes to work, obviously you launch a day later. You have to schedule your satellite coverage and your deep space network coverage. You have to issue a whole host of notifications, and some of those are to aircraft that are going to be taking observations of the vehicle during launch or during splashdown. We've notified the Navy that's providing our recovery assets. We've notified the FAA via the Eastern Range for notice to air missions. We've notified the Coast Guard for notice to mariners for any boats that are out there, for the splashdown locations of any of the jettisoned items, but also of the end of mission locations. So there's a whole host of things that the team works through to replan, and all of those notifications, but also products have been pre-planned ahead of the mission, and the team has pulled those off the shelf. They're putting the final touches on a lot of those things, and the process is flexible enough to handle that. So we're not concerned with any of those items.
Okay, we'll come back here in the front row, and then we'll move over to the other side. Right here, yep.
Chris Gephardt with NASA Spaceflight. I think these are both for Charlie. How many cutouts and colas do we have for Saturday's window? What's the longest one within there? And starting LH2 chill down on the ground side a bit early, starting to bleed a bit early, that sounds to me like you're going to lose a little bit more to boil off and a little bit more to bleed. Where does that leave you on the LH2 margins for the day? I know you have to top off the tank afterward, but like on launch day, where does that leave you for the 2-hour window?
Excellent question.
I'll start with the colas and cutouts. So I probably have a report that's in my email. We get those at L-2 day. So I haven't looked at it specific to our next opportunity, but I can tell you that for our previous opportunity, we had somewhere in the neighborhood of about 30 to 40 cutouts, so it's a fairly significant number. Most of them are really short, just a couple of seconds long. We did have a couple that were a little bit longer, maybe on the order of a minute or so. But I can absolutely get you a specific number. And then, let's see, what was the second part?
So starting the LH2 chill down in the bleed, yeah.
Starting it earlier. So we went off and analyzed that. You're absolutely correct. If you start it earlier and you start the bleed earlier, you're going to consume more. And we did go off and look at that, did the analysis. We will be able to support the entirety of the window, but we will have a little less margin in the tank when we're done.
Go at throttle up.
Okay, thank you. We'll go here next.
This question is for Mike Merfing. My name is Ada Monzon, Guapa TV, Puerto Rico. Can you elaborate on the plan of next launch windows? Even if it's not next Monday, then what are the choices or the opportunities even by the end of the month or by October?
Yeah, it's a great question. And for Jeff, I did verify that October 11th is our splashdown date, and it's a 37-day mission. So in terms of mission availability, we do have a reservation with the range for September 5th. So if we do not launch on Saturday, we'll be looking at a afternoon launch on the 5th. The 6th is in play. It's a fairly short launch window on the 6th of September. Should we not tank on the 5th, we may elect to move to the 6th. Once we get past the 6th of September, September the 19th is the earliest from a physics-based standpoint that we could pick it up. And then that launch period ends on October the 4th. Obviously, we would need to account for when did we roll back to the vehicle assembly building and what that looks like relative to where could we pick it up. We would also have to assess why did we roll back to the vehicle assembly building? Did we just simply not get lucky with weather and we had to roll back and check out the flight termination system again? Or was it a technical issue that requires access to a very specific part of the rocket? We would have to look at how long does it take to gain access, the availability of spare parts, or any reason that we would have rolled back. So there's a whole host of variables in there, but that gives you a sense of kind of the relative time frame.
Okay, let's come to the other side of the room here. We'll go to Ken Kramer.
Hi, thank you. Ken Kramer, Space Up Close. For Charlie Blackwell Thompson, please, can you talk a little bit more about the liquid hydrogen work you did on the purge can? How did you discover it? What did you do to fix it? And how do you determine it was fixed? Thank you.
So, after WDR3, we also had a leak in the purge can, and while you never want to have a leak, it did give us an opportunity to really do a very close examination of what caused that leak. And so we learned a lot from that, and we learned what are all the things that you want to go check. And we took some very specific actions after WDR3. You may recall we were setting up very similar to what we did over the last day or so out at the pad. We were getting the access in place, and then we made a decision to roll back because we wanted to go allow the GN2 production plant to make the upgrades. And so we went back to the VAB and opened up the purge can. We looked at all of the penetrations that go into that can, the soft goods associated with it, looked at the gaskets, looked at the flanges, checked all the torques, and found that there was some relaxation in the torques on the flange, and we ended up retorquing them. We made a couple of changes to the drain assist purge. You may remember seeing the pictures. It was kind of a cantilevered, arrangement into the back of the can, so it kind of put a load on there. We ended up changing that, and anyway, we came back out for WDR4. We saw good performance in the purge can. We obviously picked up the 4-inch QD leak, so that presented a different challenge for the team to go take on. But what we saw during launch attempt 1 is we saw a similar signature. We had hydrogen concentration increasing. It was fine during slow fill. It was as we got into the higher pressures and saw more flow across that interface. We were able to manage our way through it. The team was able to vary the flow rates and stay within the specifications. But certainly we saw it reoccur during drain and recognized that we needed to go take a closer look at what was causing this. So as I said, we went back into the purge can out at the pad because we'd had the opportunity after WDR3 to come up with, here's the 3 or 4 or 5 things you need to go look at. We went and checked all those same things again, and what we found is in that 8-inch in the purge can and in the 8-inch QD, there is a pressure sense line there. It's a penetration into the can and into the 8-inch there. And what happened is we found that loose, and we found that loose. So we changed out the seal around that pressure sense line. We retorqued it, and we believe that that is most likely the leak source. We checked the flange. The torques on the flange, everything was nominal. We did an inspection of the gasket. It was nominal, and we checked every other fitting there, and everything was found to be nominal. So finding that one item loose, we feel that that's most likely the cause. Now, as we've talked before, we did ambient leak checks, and afterwards, after we put it all back together, and we didn't find anything, but until you hit it with cryo, you really don't know for sure. So. No, I mean, I have to believe that it was something that's happened between when it was checked in the VAB and at the pad. So it could be from roll or from something else, but no, I don't know for certain what caused it to become loose.
Okay, we'll take here in the black shirt.
Hi, Michael Grushko, National Geographic. This is for Mike Serafin. Following up on Michael Sheets' question earlier. Earlier in the week, you gave an assessment that there was a 1 in 125 risk of loss of Orion based on all phases of flight. Now you've added 2 incremental risk acceptances to the mix, the foam and then the engine conditioning. Do you have an updated number, and if so, what is it?
We don't have an updated number. What I would say is there was no appreciable increase in risk. There was a delta risk acceptance because we know we have a crack in the foam. We have a nonconformance at the intertank flange area. We know its location. We know the approximate size, and there's a small likelihood that it could be liberated during launch, follow a very specific trajectory, and hit one specific location on a booster that could cause a problem. The likelihood of that is very low. In addition to that, as we talked with the engine bleed, the thermal conditioning, it really comes down to the fact that we haven't demonstrated it previously. We have a high confidence that we can get through this, given the indications that Dr. Blevins and John Honeycutt talked earlier. The team has more insight given where we are. We've trained it. We have a more robust plan than we had going into the launch attempt on the 29th. In terms of what that means to 1 in 125, does it change that number? Probably if you go way out in terms of decimal points, but there's no appreciable increase in risk. But we do talk about those types of things to ensure that we understand exactly what we're getting ourselves into before we commit the vehicle to flight.
And next we'll go with Kenneth Chang, and then we'll take a few more from the phone.
Hi, Ken Chang from New York Times for John Honeycutt, John Blevins. Could you explain in a little more detail what was the issue with the vent valve on Monday and how you're confident it's not an issue going forward? Thank you.
Yeah, so we did not have an issue with the vent valve. The vent valve is in the system where we had the leak. So the vent valve was inside of the inner tank. It goes to the inner tank structure, and then there's an umbilical there that vents out to the ground, and so the team saw the leak there. So it's probably better for Charlie to answer that one.
Yeah, so I think John described it really well. So this is part of the hydrogen tank vent system. Goes out the umbilical arm, very similar to when we talk about the TSMU, right? There's a ground side and a flight side plate there, and the leak that we picked up was in that particular cavity. What we believe happened is, as we have seen with QDs or quick disconnects before, is when you change the environment on them very rapidly, sometimes you will see a shift in the seal. That's actually one of our troubleshooting steps that we do when we see a leak. Is we'll let the QD warm up, and then we will allow flow back across it to see if we can get it to seat. So what had happened in the particular situation that we saw with that is we had gone all the way through our loading. Everything was fine. We had nominal performance in that QD cavity, no issues at all. But when we got into the troubleshooting of the bleed issue, that QD warmed up. We had not had, we'd had the vent valve closed, so you're not really venting through that area, and you got it warmed up for quite an amount of time. And then when we opened it and we exposed it to a very rapid change in environment, both temperature and pressure, that's when we picked up the leak there. And as a matter of course, as we went through the drain operations a little bit later, and you saw, the QD chilled down, you actually saw nominal, the leak kind of sealed itself. So that's why we have confidence going into our next tanking operation. Again, we've seen this in the past where you've had rapid change in temperature and pressure. Sometimes you'll see some change in the seal, and that's what we believe caused the issue that we had on our launch temp 1.
Okay, we'll take a few from the phone. We'll go to Marina Corin with The Atlantic.
Hi, I'm Marina Corin with The Atlantic. A question for Mike Serafin. A few days before the first launch attempt, you said that if you couldn't successfully demonstrate the thermal conditioning of the engines, you wouldn't be launching that day. Now that you're confident that you'll be able to do that on Saturday, what else is on the table, something of a similar nature that you haven't tested yet that you can say today could be another showstopper?
That's a good question, Marina. Certainly, we have nearly 500 launch commit criteria, and 489 launch commit criteria. Any one of which affects our overall risk posture headed into the launch attempt. So this was one particular situation that coming out the engine thermal conditioning was one particular and very unique situation that we carried out of the agency flight readiness review as a known first-time demonstration in the launch countdown. Unlike the other launch commit criteria, we just knew that this was something that we had to do successfully for the first time. The other launch commit criteria, obviously we've got to meet those or we get into elevated risk acceptance, and we do reserve the right to do that, but it would have to have adequate flight rationale. So, things like weather and a whole host of other criteria are part of our launch commit. So we will wait and see what the conditions are, and we will go when the vehicle is ready and we understand the risk posture.
Okay, we'll take another from the phone. We'll go to Ramin Skiba with Wired.
Hi, thank you. My question was answered, but I'll ask something else. I guess this is for Mike Serafin. I was just curious, will the Vice President or any Congress members or celebrity guests be in attendance on Saturday?
Obviously, Artemis 1 and this initial launch of the Space Launch System rocket and the Orion spacecraft around the moon is gathering and garnering a lot of attention nationally and internationally. We will have VIPs here. I don't have specifics on who the VIPs will be, but I would be surprised if there were not congressional stakeholders here.
Okay, and we'll come back to the room here. We'll go here in the hat.
Kristen Fisher with CNN. I've got one more question about the bad sensors, so I think this is for one of the Johns. But I just want to try to simplify it a little bit. Given that you have confirmed that this is a bad sensor now, is part of the plan, is part of the risk posture for this second launch attempt to simply ignore it?
Yeah, let me answer that. It's not a risk posture per se, because what we always wanted to do is confirm that we could get liquid in for a certain amount of time to chill the engine, and now we've confirmed that. So we weren't going to use this instrument for that purpose once we confirmed it, and now we've confirmed it. So I don't know, to me, if I would call that an increased risk posture going into launch. I think the risk that remains is that we haven't gotten to our first launch of the program yet. What's the risk in ignoring that sensor?
Is part of the plan, is one of the things that you all could do on launch day is just to ignore the sensor, the bad sensor. Would you just ignore it?
Yes, we will.
Okay. Thank you.
Yeah.
Okay, we'll go in the next row back.
Manuel Masanti from Debate. So if you can ignore that sensor, can you ignore the other three? So you have three, you are one sensor per engine, right?
Yeah, there are three more sensors.
So can you ignore the four of them?
We use those to make sure the initial flow looks cold, and we're going to try to take a look at that. We have other witnesses, and we know those witnesses well now that we've done this test. And so, I won't say that we're ignoring them, but I will say that we have witnesses what Charlie's doing for the engines is early in the count, and we will have sufficient time to verify we've got good liquid in the engines, regardless of what any of those sensors do.
Okay, we'll go back and take a couple from the phone. Next up is David Curley with the Discovery Channel.
Thanks very much. Honeycutt or Charlie, what are your tolerances? What is the margin? I asked this a couple of days ago. When hydrogen's coming out into the vent tube, what temperature should it be at? If you're trying to get to minus 420, what it should be at? And Seraphin, big picture, we're in the weeds here. We're Thursday after a scrub going into the next launch. What do you think and how are you feeling?
Temperature. Yeah, what we're looking for roughly is, well, we're looking for saturation temperature, and that's a function of pressure, and it's around minus 420 F, as you mentioned. I'm not sure what you're asking about. There is margin between that. There's roughly 40 degrees Fahrenheit margin between what we need the bearing to be and what we're looking for the liquid to be. And with the time that we're using, we will have plenty of cold fluid through there. So, ultimately, this process really ensures there's virtually no risk that that bearing isn't at the right temperature. So I don't know how to measure that in any kind of quantitative margin. I would just suggest we verify that we can chill the engines properly.
Okay, and David, in terms of what am I thinking, what am I feeling, we got to show up, we got to be ready, and we got to see what the day brings. And, we've got a whole host of things that could cause us to not get off any given day, weather, range, or technical. And those are the three big buckets. We talked about the 489 launch commit criteria. Those are the technical reasons we might not launch that day. And we've got the weather forecast is favorable. We might find that a combination of technical issues or somebody being out there on the range that shouldn't be out there from a public safety standpoint, and just a cloud cell or that kind of stuff could cause us to miss the opportunity. There's no guarantee that we're going to get off on the 3rd, but we're going to show up and we're going to try and we're going to give it our best.
We'll take another question from the phone and then come back to the room. Next up, we have Tim Fernholz with Quartz.
Hi there, this is Tim Fernholz from Quartz. Thanks for taking my question. I hope we get a launch on Saturday, but I'm curious, can you tell us a little bit more about the eclipse violation? I know obviously that wasn't one of the days that was originally hoped for a launch. What are the risks associated with that later on in the flight, and why are you accepting them now? Thanks.
Yeah, Tim, I'll say that the finding or the analysis that was brought forward at today's mission management team meeting was some relatively late analysis. Normally, the team prioritizes the normal mission plan first, the mission you intend to fly, and they go off and they analyze that, and they did that work. And then they start looking at all the what-if cases. What if we have a performance problem? What if we have a battery problem? What if we have a solar array problem? And this was one of those what-if cases, and it came back and it showed that we had a significant power deficit if we had a performance problem, and we expect the rocket to perform fine. We've looked at our performance margins. We have over 20,000 pounds of margin to our guided cutoff at the insertion altitude, and we have over 2,000 pounds of margin to the point of translunar injection. But the power deficit, should we have a performance problem through the point of translunar injection, was to the point where we did not think we could manage it on the Orion spacecraft side, just due to the geometry between the sun, the Earth, and the spacecraft as it was headed outbound towards the moon on that outbound leg. So we took it off the plate. That said, it's likely to be a moot point once we tank on the 3rd. The 4th is off the plate anyway, simply from a commodity standpoint. So it was just a part of our look ahead, and it was, as I said earlier, the result of a what-if case that came in fairly late.
Okay, and we'll take one final question here in the room, and then we'll go ahead and wrap up. We'll go in the second row here.
Hi, Sophie Sanchez from Cosmic Chicago with Chicago Now. I think my question would be best posed to Charlie. Tuesday's briefing kind of brought up memories of the ICE team and the work they did during the final inspections of the pad, looking at things like abnormal engine temperatures and foam falling off due to cracks. What role do they have, if any, in final inspections of SLS? And did they provide you with any information or data during the countdown, or was it all coming back from the sensors, the data gathered? Thank you.
So the ICE team is a really important part of my launch team, just like they were back in the space shuttle. And one of the things that they do today, just like they did back then, is they provide an L-1 hour report on all of their findings. One of the differences is that they utilize high-res cameras out at the pad, and we've specifically placed additional cameras so that they have multiple views, and they can look at that without having to be deployed to the pad. So we've allowed technology to assist them in doing their job, but the report, in terms of the kinds of things that they're looking for, the report that they make is very similar to what they did with shuttle. It's just that they're doing it remotely. And we also have the capability, should we ever need to, if we had something where we felt like we needed to send them to the pad, we certainly have the capability to do that. We could send them in as a red crew to go evaluate something very specific. But what we have found is that the imagery that we get back in the control center has been more than adequate to evaluate all the different areas and the performance of the core stage.
Okay, thank you. With that, I'd like to thank everyone for joining us today. We will have another pre-launch status briefing tomorrow morning at 9 a.m. Eastern, and our coverage of tanking operations starts on NASA TV Saturday at 5:45 a.m. Eastern, with our full launch coverage starting at 12:15 p.m., and our Spanish language coverage starts at 1 p.m. You can find more on our coverage plans and on the mission at nasa.gov/Artemis.
Dang it. Dang it! Okay. Oh, wait, hold on. OSB 2 camera. Oh. No Friday night race. Oh, crap.
Discovery, go at throttle up.
Oh, boy. I gotta get my coffee machine working. So they're gonna try tonight. No. I see you chuckle. I think my video was out. You shut up. Don't leave me that stuff turned up. Trying to pay attention. Trying to pay attention, you dork. We can only do one race. Yeah, one race is fair. They said they're going to begin tanking at 5:57 max. That's when I got to be here. Yep. Correct. Yeah. Yeah. Guys, some of the press, I don't particularly like some of the press's questions, but I'm not gonna say that they shouldn't ask them either. Sometimes the press has to ask dumb questions to get stuff on the record. It's kind of a thing. It looks better in an article that you're going to write if rather than just saying, oh, NASA says that this is going to work, right? I asked da-da-da-da-da at NASA, and they said that this is going to work. It's probably better for a news article, I would say. What question would I have asked? Smoked, I don't ask questions, dude. I don't ask, because the information that's presented, dude, the information that's presented takes a second for me to process. Like, I wouldn't be able to process it in the time that it takes to ask a question. You know what I mean? They honestly, with this particular one, I really wouldn't have had any questions. All NASA did was basically confirm what I basically said the other day. But that, once again, if you know anything about spaceflight, like I'm not saying, oh, well, if you knew anything, if you know, like the people that know, like if you know that this was the answer, this is what they were gonna say. John Honeycutt in the presser the other day heavily indicated that they were getting cold flow on all 4 engines. So it strongly pointed to a bad sensor. And I'll be honest with you guys, from what I heard there, the sensor doesn't even sound like the sensor's bad. From what John Blevins was saying, it sounds like the connection to the sensor is bad. Yeah, that's what that sounds like. When you get a partial reading on something, or you get a reading fall off, because that sensor was in concurrence, basically until, like right up until when they went full cryo on engine bleed. If a sensor is in concurrence all that time, and then it goes out of family for a second, yeah, that sounds like it's just not plugged in all the way. That's possible. Could be a bad ground. Could be something that simple. Dude, I would even say that the sensor isn't even bad. That DFI sensor is not even bad. That's just my gut, though. I read somewhere that the engine was at 390. John Honeycutt Hellfish said 380, and he said it was 30 degrees out of family. And then he said 380 after that, and it's supposed to be at 420. It was at 390. Yeah. Question for you. Why do they still use external insulation after all the shuttle had nothing to do with... Oh, Roadrunner, you get better performance with that stuff. Insulating the hydrogen tank? Oh, you get way better performance, dude. Oh, yeah. That performance was required to move that big brick of a freaking orbiter on the side all the way up, and obviously you don't want to have ice hitting the orbiter's thermal protection system. But a lot of implementation, the best type of implementations are twofold. 2 birds with 1 stone. You know what I'm saying? Hey, Vega, 17-month resub. Yeah, it could have come loose on the roll, just like the catch can pressure valve, or the catch can pressure sensor. Oh, no problem. Smoke, don't apologize. But yeah, guys, I generally don't ask questions. I could ask questions if I really want to. I really like listening. I like doing this, what we're doing right here. I gotta like talk myself through it, and chatting it out with you guys actually does really help kind of reinforce it in my head. But I also like listening. It's so important with this stuff because a lot of information, like Mike Seraphin, John Honeycutt, and John Blevins and Charlie there, they all dropped a lot of info very, very quickly. So it's a lot of information coming at you very fast, and not only is a lot of information coming at you very fast, it's a lot of information that you had to have a lot of prior knowledge about to really understand. That's why I sit there and I listen. It's very, very important. Since they said they're out of the launch window for the 6th, does that mean they won't fly? Does that mean if they don't fly Saturday, we're screwed? No. No, there's the 5th. You like to understand it so you can explain it in the way that you guys can understand. Pretty much. So yeah, if you guys want a quick kind of short answer to what happened, the press conference the other day, NASA said they needed to prove to verify that sensor was actually not giving a good reading. And once again, if I had to guess, it's probably just not plugged in all the way, or something came loose somewhere. That happens. It happens. But fortunately, NASA had other ways to prove with numbers that all 4 engines were chilling down correctly. They proved it. They retorqued the catch can bolts. And the frost that accumulated up on the core stage hydrogen vent was because they cooled it down too much and it caused the leak, and the leak causes frost, and that frost caused a crack. There are 2 cracks on the inner stage. They are low risk, minimal probability of causing any problems. Doesn't NASA take questions from the press to catch any questions they missed? Would you even consider trying to get in there with a question or 2 after you mull over it? I have to mull over it first, Aqualux. Like, how can you some of these guys have a talent. Like Chris G has a damn good talent for that. That's a talent that I just don't have. And that talent is being able to ask these questions and ask these questions reactively to NASA based off of what they told you like literally 5 minutes ago. That's a lot of stuff to balance in your head. I don't do that very well. That's why I got to sit here and that's why I listen, because I mean I would say I don't want to ask a dumb question, but I would rather sit here and take time and hone in and try to understand what's going on rather than ask a question that isn't the right question to ask. And what do I mean about the right question to ask? Well, I would have asked one of Chris G's questions about hydrogen commodities. That second, he asked about colas, which I'm not too familiar with. Colas and cutouts, I'm not 100% familiar with those, I'm not going to lie. The second part of his question that had to do with hydrogen commodities, that's the question I would have asked. And that would have been based off of the other press conference, not necessarily this one. You do know far more than the press does, though. Well, yeah, Astro, because I sit here and I analyze the data. I do exactly what NASA says to do. I sit there and I listen. I listen and I analyze and I make. I just want to sit there and be like, oh, I analyze this and I analyze that and I analyze it. Like, no, I sit there and I listen and I try to soak it in as much as I can. Yeah, dope. There you go. I try to get at least one question typed out before I call in. Always easier having a script versus asking a queue. But if you do that, Grapes, you're gonna miss another person asking potentially the same question as you. I don't want to do that. I don't want to waste NASA's time. I like listening. This is not like something that I probably should. I probably should ask questions, but when I'm learning something, dude, it's so easy for me to miss something, especially with rocket science. Especially on top of that, since I need to teach it to you guys. Not need to. It pays to talk it out here. And maybe if I was like doing regular press stuff, I'd probably have a good question to ask. But the fact that I need to re-explain, I need to go and I need to explain. I'm going to get asked this question probably about 20 times between now and the launch, which is fine. I like to sit there and I really like to take in every single word that they're saying and then, put it all, string together the puzzle pieces together later, Hey, AJ, what was the rocket engine book you recommend again? I think you said it was the 9th edition. Rocket Propulsive Elements, 9th edition by George Sutton. Yeah, that's like the holy grail of rocket science. Exactly, so it would be a far better question than most of the press would be capable of. Yeah, but Astro, the press conferences is long over by the time I come to these conclusions, Listening and then perhaps asking a question. Listening pays off more. Yeah, Celtic, it pays off more every time because it pays off more every time because I get to weigh all the data. I won't have a question based off of the data that was just given. I won't really have a question until at least 30 minutes to an hour of figuring out what the heck they're saying because it's rocket science, man. It's tough. You could email the questions in later. Yeah, sure. I appreciate you explaining everything in an easier way, breaking it down. I try to, yeah. I hate small nitpicking people. I did get a little annoyed with some of the questions, but you got to remember, some people are in that same boat as me. You know what I mean? They don't know what question to ask. They don't know what the information was that was presented. Dude, I know the information that was presented. I understood pretty much everything they were saying, except for colas and cutouts. It's the only thing in that entire press conference that I didn't understand. And I still am hesitant to ask a question. I know that people want to ask, they're going to ask a question just for the sake of asking a question, and that's annoying. It's annoying to me. It's annoying to me for multiple reasons. They answered the question. They answered the question. They answered most, like, all the information. Like, there were a couple of press questions where I learned a couple of new things. But the vast majority of those questions were answered in the presenting body of material that was at the very beginning of the press conference. And once again, I get it. The press is going to have to ask their own questions. I get it. They want to ask it to get it on the record. I understand that. I don't mind people regurgitating the question and then asking it again. Like that's what Lauren Grush did. I think she's from Bloomberg. Lauren Grush she's a pretty good reporter. She does a good job. And she asked the question again, kind of in her own way. That's why we get a lot of repeat questions, because everybody wants to. I don't know if it's like proving to NASA that you know the material or something, being able to rephrase and ask it in your own way or something. I don't know what that's about, but some of those questions were. Some of the questions that you get are just gotcha questions. That's what I call them. They're gotcha questions. Like the CNN lady tried to do that. And that I don't like stuff like that. You know, I'm a firm... Like, you can call me a piece of crap for this. Like, that's fair. I wouldn't say that I'm not. I don't like gotcha questions in spaceflight. Because spaceflight is captivating in itself. You don't need a story with spaceflight. Spaceflight is the story. Like, look at movies. Look at movies about spaceflight. Look at Apollo 13. You don't. That's the story. You don't need to hype it up. It's spaceflight. It's already cool, and it already gets people's attention. So I don't like it when they ask the gotcha questions. One, because the people that ask the gotcha questions literally have no idea what the hell they're talking about. And two, you don't need to. And you could say I'm gatekeeping it. You could say I'm a piece of trash for it. That's fine. That's fair. You'd probably be right. It's when you get this far into it as like learning about this stuff, and dude, I know I'm not gonna sit here and be like, well, I know more than everybody else. That's such a dick thing to say. That's so pretentious. I don't. I know more than maybe the average person, right? Like, that's not interested in spaceflight. I'm no engineer, that's for sure. Like, I know a good deal about this stuff, and I still like, I know enough to know when people ask questions, and they're just there to ask a question. They're just using up oxygen. You know what I mean? Like, it's a non-question. Like, it's very easy for me to spot what questions you're asking to get on the record, what questions you're asking because you generally want to learn, and what questions you're asking because you're trying to get, oh, gotcha. It's really easy to spot those because that's literally all I do every day for 12 hours a day, and I've been doing that for like the last 7 years. I know the gotcha questions. I know the questions that people ask that are generally want to, like, dude, I get asked these questions all the time. You know what I mean? It's really easy to spot, and it's annoying. It's annoying because in my opinion, all they're doing is making themselves look stupid. But whatever. Like, one of the questions they laughed at. Everybody in the room laughed at it. You guys missed that part? Exactly, Staples. That's what I mean. Well, you don't want to know what VIPs are going to be here? Actually, you know what, IQ2? I didn't have a problem with that question because at least the guy from Wired was... See, the guy from Wired was smart enough to say, like, look, my question was already answered. You got it. You're good. I don't have another question. Who's going to be there? Screw it. He threw his hat into the ring. I don't mind that. That's fine. His question already got answered. Thank you for being honest and just not asking the same damn question again. You know what I mean? What about the other four? Yeah, see, that's what I mean. That's what I mean, 2020. That's fishing. That guy was fishing for stuff. He was fishing for something. Like, dude. The other four are fine. They were fine. They've been fine this whole time. Why would you ignore them if they're fine? And that phrase, you're in the weeds. Yeah. Yeah. It's just stuff like that. Like, I'm sorry. And, like, once again, you know, fellas, if you think I'm a piece of crap for For being like, that's a dumb question. That was a dumb question. You're right. You're probably right. Like, I'm not gonna sit here and say that it's not a dick thing to do. Like, I don't know. I guess I'm not perfect. Yeah, smoked. I don't know. Like, fellas, this used to bother me a lot more because, dude, when I really started covering press conferences, I noticed that a lot of the questions were just horrible questions. Like, a lot of them were gotcha questions. And then, and I think that has a lot to do with people didn't like Jim Bridenstine. They weren't sure if he was proven or not. So they asked him a lot of stupid questions. But it got better towards the end of Jim, and now it's not too bad, you know? My issue with SLS is, for the money, NASA could do so much better. Sure about that? So when figuring out the issues with Artemis, how would they do that? Did they roll it back? No, they didn't roll it back. If you decide to call in, formulate a question based off of prior conferences. If it's asked before they get to you, just bow out or exit the queue. Pretty much, Novus, yeah. Like, Chris's question was great, and Novus, that would have been my question if I was going to ask one. You know, what's the hydrogen commodities look like? Because I know you changed the fueling procedure to accommodate for a different tank than what you had at Stennis. That would have been my question. Chris asked that question. That's what Chris G asked. Chris Goatheart, because freaking goat of all questions. That was a great question. Yeah, Arbalest, that's the thing with spaceflight. That's something that I would like to tell most journalists. And like, Chris G knows this, Jeff Faust knows this, Bill Harwood knows this, Marcia Dunn, Marcia Smith know this. Like, you don't need to ask gotcha questions with NASA. They'll just tell you. They'll tell you what's going on. They have to. They'll tell you if there even is a failure. They have to. You know, you don't need to be like, the lady from CNN, her second question was actually a really good question, and then she pushed the issue. You know, what are you going to do about that sensor? And then John Blevins actually gave a really, 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 really good, very in-depth answer about how they assess risk on sensors and how they prove it with data. That was awesome. That's the best part. That's a good question. And she said, "Well, you're going to ignore it then?" Like, it's like, all right. That was actually a really good question. And then, you know, he gave an answer basically saying, like, we've proved that sensor is malfunctioning. And all we needed that sensor to do was to make sure that the high pressure fuel turbo pump rotating bearings don't spin during the start, because that's a failure mode that can happen. We were talking about hard starts and what they do. They wear engine components to the point where they can blow up, because you get detonations and all kinds of other stuff. In this case, they don't want to spin the bearings on the turbo pump. No, not the bearing itself. Spin the housing of the bearing. That can happen if it's not to the right temperature. If you thermally shock load the bearing, it'll break. Funny story. You know, he gave a whole explanation on that thing, and she said, "So you're just going to ignore the sensor?" It's like, huh? What was it? Mars Direct was a much better plan, IMO, than SLS. Constellation was better than them all, Elios. And ain't nobody gonna convince me that Constellation would have been more expensive than this thing. Ain't nobody gonna convince me of that, dude. Am I right or am I right? I love how he committed to the "yes, we're going to ignore it" answer, because, yeah, exactly. It's disrespectful. It's very disrespectful. He gave a great answer on the sensors and how they work and why they work, and she goes, "So you're just gonna ignore it then?" He's like, Yes. Is that what you want me to say? He's just like, all right, fine. You see, John Blevins realized that it was a gotcha question. He just said, yeah. It's a great lander, isn't it, Astro? No, Airbenis, they laughed at Marina Corin's question. I don't even remember what it was because it was so incredibly distracting. I don't remember. I don't remember what it was. CNN's got a lot worse than the last 6 months a year. The best person on CNN I know would have Seagrain on CNN 5 years ago. Yeah, and man, I don't know, dude. I don't know. Like, man, my thing is like all these resources that CNN has. That's what you're gonna do. All these resources, you're gonna basically reduce this whole damn thing to a gotcha question about ignoring sensors that are not even instrumental to flight operations on the vehicle. Congratulations, you just played yourself. Yeah, Carstaller, I get it. Yeah, no, I know. People looking for a gotcha. That's what I mean about gotcha questions, and everyone asks gotcha questions. It's really annoying. You know? Yeah, Jax, it is what it is. And don't get me wrong, I'm not trying to be like, oh, this station is bad, this station, I don't care about that. We're talking about spaceflight. You know, I didn't like the Nat Geo guy's question about loss of crew. That guy has no idea what he's talking about. I will tell you that right now. I can say that with a very high degree of confidence that he has no clue what he just asked. What he just asked. You have no idea what you just said. It's pretty obvious. It just validates your channel. Yeah, all right, whatever. Yeah, man, yeah, no. You remember the Gulf War? Remember seeing him in the Gulf War? That's what I'm talking about, dude. Give me some of that. Geek, I'm not trying to stir the pot, dude. That's other people's jobs. We're talking about spaceflight here, right? Sometimes I like stirring the pot, dude, but it's probably not here. You know what? This is about spaceflight, right? The Nat Geo guy's question. He asked. He put in a bunch of big words to try and make it sound fancy, but he basically said, you know, with these problems that you're having, your reports rated the Orion loss of crew at 1 and 2. What was it, 2 something? He said, oh, you know, has these issues with the core stage affected Orion's probability of loss of vehicle? That seems like a smart question to ask. It seems like it, but you're missing a fundamental premise. That's what Marina Corin's question was. I think that was her question. Somebody in there asked, oh no, it was Mike Sheets. Mike Sheets asked this question. He said, if you put people on it, would you be this in favor of going? Trying to basically ask if they're getting go fever or not, which is literally dude. Mike, why would you ask that? He said, oh yeah, 1 in 125. That's what it was. He asked if these teething problems that they're having with core stage cooldown is going to affect. He asked if those are going to affect the probability of Orion mission success. Basically saying, are you more likely to lose the crew because you had a bad developmental sensor that's not crucial to flight? It's yeah, see, that's what I mean. That's what I mean about not knowing what you're talking about. And don't get me wrong, guys. I ain't perfect. I do this. I'm learning all the time. And maybe so are these people. And that's why, you know, don't go be a dick to these people. Like, that's not cool. Like, he basically asked them if a developmental flight sensor is going to affect the probability of loss of crew on the vehicle. So that is like asking, is my floor jack going to affect my car's reliability? What? And then the other question was, would you be this willing to recycle and launch this thing if there was crew on it? That was probably the stupidest question asked. This is a test flight regime. They're doing this now to get crew on it later. This method, the way that they're going about at this launch campaign, people aren't part of this equation. That's like going into an algebra class and asking a calculus question. Because they're both math. Oh, it's both math, right? Like, it's like, nope, not, yeah, maybe a little bit, but nope. Yeah, like are the tools you're using to diagnose my car going to increase the risk of a car accident? Yeah. Is my OBD2 sensor going to cause a flat tire? It's like, what? What? I mean, it could on a really heavy technicality. No, it couldn't. The DFI sensors are not. And that was another question. They said, could these cause? Are these sensors, vital to the mission? No, they're not. They don't even use them. They're not part of the ALS. They're not part of the automatic launch sequencer. The computer is not connected to those sensors. The flight computer is not connected to those damn things. They're for instrumentation. I'm trying to think of a good analogy. I can't even think of it. Long story short, it's a totally different system. It's not connected to the flight computer. I.e., the flight computer is not going to use that DFI sensor to determine whether hydrogen is flowing. It's going to use the onboard sensors, the operational flight instrumentation, the ones that are designed to be there on all subsequent SLS missions. These ones are to just help verify the data. You always add instrumentation on a first flight. Always. Because you got to know. You got to be absolutely sure. What was her question? A few days before the first launch attempt, you said that if you couldn't successfully demonstrate the thermal conditioning of the engines, you wouldn't be launching that day. Now that you're confident that you will be able to do that on Saturday, what else is on the table? What else is on the table? Something of a similar nature that you haven't tested that you can say today could be another showstopper. Ugh. Thomas, I'm not gonna. That one is. Hey, have you tried just predicting the future? He asked that loss of vehicle question in reference to the foam crack as well. A decent question, but asked in a very headline-esque way. Yeah, no, but I get it. I know what he was trying. Yeah, I understand. Even though is Orion near the foam? Okay, let's talk it through. Is Orion near the foam? No, not near the foam. Okay, so what else could what else? How could the foam possibly affect Orion's mission? So, what's the foam there for? In Novus, I know you know this. What's the foam on the SLS core there for? It's there for thermally insulating the core, thermally insulating the propellants. And it was originally put in place, the spray-on foam insulation was originally put in place so ice didn't come off of the external tank and hit the shuttle's thermal protection system. Now that second one, I'm pretty sure you don't need to worry about that because there's no space shuttle. So the first one, you could get off-nominal performance because you couldn't thermally insulate the propellants correctly. In which case, there's no way NASA doesn't have an abort contingency. In fact, they've talked about the abort contingencies in a previous They've talked about abort contingencies in a previous press conference that we watched, and I believe the question about abort contingencies was literally asked by that guy. If I'm recalling that correctly. I answered it perfectly. A strike to the booster could be serious, but it's very unlikely. Yep, yep. The entire foam layer could peel off at launch without affecting flight performance, right? If the entire foam on the thing came off floating, we'd have a big problem. Yeah, because it'll find something. It'll find something to break. In terms of temperatures, it's hard to say. I'm gonna give you the NASA answer. That's hard to say. That is such a ridiculous scenario that NASA probably hasn't even considered it. Sorry for asking. What time is the launch? More so I can get up in time. It's 2:17 p.m. on Saturday, Mousewolf. I think the only thing they were worried about hitting was the SEP motors on the aft skirt, but those are less fragile than the belly of the shuttle. Yep, yep. Yeah, colas and cutouts, Snibbles. I gotta go read about those. I don't know what I didn't understand that part of Chris's question. Hunster, I'll be honest with you. I don't guys. I want to be very clear. I'm not trying to say that the press shouldn't ask these questions. I'm trying to say that it annoys me. Like that's the thing. It annoys me because it's missing. They shouldn't not ask these questions. The press should be able to ask whatever the heck they want. They should be able to ask Mike Serafin where the damn bathroom is. All right. You know. What do you reckon you'll start the stream? 5:30. 5:30 a.m. I'm coming up. I'm gonna be here right before they start tanking the entire launch campaign, just like I was before. Was asking since Ariane 5 and in China trying to peel off the part of the insulation at launch. Yeah, the spray-on foam insulation on SLS floating does not do that. If you want to see how well foam hangs to stuff, take a look at the LH2 SDA tank rupture and how much it flexes with the metal. Oh, there you go. Actually, Novus, that's good. Alex, what's your... It's like having a GPS in the back seat. It's going to tell a passenger where it's going, but the driver is going to use other means to navigate. Yeah, pretty much. Like, fellas, I want to be very clear. The press shouldn't, like, dude, even Eric Berger, he can ask whatever he wants. I don't care. I know what he's going to do, and that it annoys me. But you shouldn't have suppression of press. That's a really stupid thing to do. Yeah, Rev. Yeah, exactly. That's why it annoys me, because they're. And once again, just because it annoys me doesn't mean it's a thing that shouldn't be allowed. You know what I mean? I don't work like that. That's really stupid. Like, oh, I don't like this, so we should ban it. Yeah, funny. You know that they're going to use it to dump on SLS when in reality they have no idea what they're talking about, and that's what bothers me. They're putting out junk. They're putting out junk stories about stuff that they don't know about. It's the disrespect. That's what pisses me off. Like, you don't care about spaceflight. You don't care. You don't care, and that's literally your job. You're not there to learn. You're not there, Yeah, it's really annoying. Especially when op-ed becomes a part of it. But once again, I'm not going to sit here and say they shouldn't ask. To be honest, I just watched the SDA rupture again. 3% deviation, Novus, after 3 hours, man. It's damn impressive, dude. I'll say that once, I'll say it again. The problem is they're putting up junk stories that other people will take as fact. Worse, Reddit, they're not even putting out a junk story. They're putting out their opinion. That's annoying. It's especially disrespectful. Like, don't get me wrong. People can write op-ed pieces all the time. But it's especially disrespectful because NASA has to be transparent, so they have to give you answers. And it's disrespectful because these people, it's like peak Dunning-Kruger, man. Like, oh, I'm a space reporter. I've been to a couple press conferences and stuff, blah, 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 blah. And then they go and write articles about it. And the articles don't even mean bad information. It's just their interpretation of said information. It's not that the information is bad. The interpretation is terrible. And that's what gets used. Oh, that's what gets used is, you know, oh, this sucks, this sucks, this sucks. Like, that right there is the biggest problem that I have with the spaceflight community. That's the biggest problem. There is an army of people out there that hate what NASA does, and like they're just like, oh, SpaceX, 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 private market, private market, private market, because they've, and it's not that it's not even that the information is bad. It's just it's being explained from a point of view. It's not being explained as factual, and that over the course of 5 years, you know, I have to do every time we even talk about SLS. I can't go one conversation about it without somebody spouting some of this junk regurgitated information. Like, and guys, I've been doing this for such a dang long time. I've been doing this for such a long time. I know where the sources come from. If somebody comes in here and says like, "Oh, I think SLS is too expensive," I know what article you freaking read. I know exactly what article you read. I keep up with that stuff just to be sure. The amount of people that just go and spout regurgitated opinion off of an opinion piece that's being touted as fact in this whole spaceflight community is kind of alarming. Yeah, that's why I keep doing what I'm doing, because I'm trying to change that. Yeah, Novus, I know. ICBS bad, US good. Now that I agree with 2020. Bet, what article? What do you mean, Smoked? Okay, Smoked, you want to play off a conversation? This is how much I track stuff in my head. You and I had a conversation the other day, and you asked me, who do you think is going to get to the moon first, SpaceX or NASA? What did I say? I said, well, they're not competing with each other. They're not competing with each other. They're working together. NASA's going to use SpaceX lander to land on the moon, right? We had this conversation. This was like 3 or 4 days ago, right? Then what? Then what did I say? Do you remember? I remember. That's right, Astro. Mm-hmm. The EGSA is too expensive. Nice. They'll get there about the same time. Smoked. I know what you're typing because I remember I was there. No, I didn't say who would get there first. Are you sure? You asked me. Nice thing, bird. Oh wait, no, I don't like the vents. No, not nice. Screw you. Dude, I think it was someone else, but I do remember the conversation. Run the VOD. Smoked, I could have sworn it was you. You did ask another question about SLS, and I don't remember what it was. I could have sworn that was you. You got to pull up the chat logs. No, either way, I had a whole conversation about this, and it apparently wasn't you. So, or you're screwing with me really hard. If so, appreciate the effort. So, Smoked, you said bet. What article? Okay, what question did you ask then? I didn't explain my questions right. Oh, okay, all good. Gotta remember, most of it you read a single story about spaceflight events. Most of the time, it's strictly headlines and bylines. And God, what I'm trying to tell you is that you don't need to hype that up. You don't need to twist it. You don't need to do any of that. You just report the news. That's what NASA spaceflight does. Look at how successful they are. Just saying. Do not quote the deep magic to me, which I was there when it was written. Either way, guys, like I want to be very clear that some of these questions do kind of piss me off, but I don't want the press to not be able to ask these questions. That's really stupid. Like, I want to be very, very clear. I know, I did say something about NASA and SpaceX together, though. Dude, that's what you asked. I'm pretty damn sure. You asked who's going to get to the moon first. And then I said, where'd you get that from? Where'd you get that idea from? I'm genuinely curious. Actually, no. You asked that question and I answered it, Smoked, and then like an hour later, somebody else asked the same question, and then I asked them, where did you hear this from? But anyway, guys, I like to do that. I go and read all the articles. I do that because I like doing it. It's what I like doing. It's a little weird, but hey, whatever. Yeah, Hunster, I asked, where did you hear this? Where did you get that from? Did you read it on Reddit or something? Yeah, it's Celtic, right? Ugh. That's not I forget spaceflight. They said, oh, I saw it somewhere or saw a headline or something. Hunster, I don't know. You kind of have to freaking be in this business. Tim Dodd does have a video titled NASA versus SpaceX. Yeah. Answers with Joe titled a video, and the video wasn't even about SLS or Starship, but I clicked off. That was most likely what happened. Sorry, Bo. Didn't indeed to be argumentative or anything. No disrespect. I'm just trying to learn. Smoked. You said that. You said that the other day. Do you not remember this part? No, I said it's fine, and then I said after that, no, it's no problem if you're asking from a point of innocence. If you generally want to learn, there's no stupid questions. Hey, Adam, what's up, dude? And that's what I mean. Like, I don't know these people's levels of knowledge. I don't know how much they know about the spacecraft, so I kind of shouldn't be a dick. But on the flip side of that is that every press conference I've watched usually has the same people in it, and some people just keep asking stupid questions. It's a pattern that I've noticed. It was a dream, man. Yeah, maybe. I'll suspect you'll see SpaceX put a standard Starship around the moon to test new tech, navs, communications, then bring it back prior to sending the initial lander test article. That would line up Staples with Dear Moon. I bet deep down what's really pissing you off about the reporters is that they're wasting everyone's time promoting their opinion, where that time could be used to get better and more in-depth information. Yeah, Aqualex, I used to think that was it, but then again, if I'm worried about the continuity and the depth of the question, why don't I ask my own? And I don't like asking my own. That's what I mean about me not being able to do that correctly. So, should people just not be allowed to ask questions? No. If I'm not going to ask a question and not waste anybody's time, maybe I should shut the hell up. And that's what I mean. And that's why I said when we went off this, right when the press conference finished, I'm not going to lie to you. It annoys the piss out of me. But I'm not going to say that these people can't ask questions either. They should be able to ask whatever they want. They should be able to ask where the damn bathroom is. Right? It has to be that way. It's a double-edged sword. Did the moon landing really happen? Sure, Hannibal. Yeah, absolutely. And no, before you even, like, okay, Hannibal, okay, are you trolling me? If you're trolling me, no, the moon is a dinner plate that flies through space. If you really want to know, I can prove it to you pretty reasonably. Like, I don't have some crazy scientific explanation. I have a pretty straightforward explanation. If you really want to know, you got to tell me though. Yeah, Geeson, everything is good. There was no problem with the RS-25, believe it or not. They proved that NASA isolated and proved that it was a bad sensor. In fact, they got it down to the point, they explained it in such detail where you could pretty much pinpoint that it was a bad connection and not a sensor. So, Hannibal, you tell me, just say yes or no if you want me to actually tell you. I mean, you know what? Whatever. We've piqued everybody's curiosity. These questions always... Continue, please. Want to know? Yes, absolutely. I can give you one straightforward, conclusive answer amongst anything else that says that we went to the moon. You know what it is? The Soviet Union said we did. They did. Soviet Union said we did. Why would they do that? Why would they do that? Straight up. Why would they do that? Why would they do that? Think about it. Why would they say that? Okay, let's play through it. Why would they say that? Maybe we fooled them. Maybe we fooled them. And maybe we were somehow able to put up some kind of weird screen and we fooled them and blah, blah. Okay, so if we play off that notion that we fooled the Russians into going to the moon and it was actually a hoax, you're going to try to make the argument that the country that sent the first satellite, the first person, first EVA, first rendezvous, like you're going to try to tell me that they don't know anything about space? First country to land on Venus? You're going to tell me they don't know what they're talking about? Hard sell. That's it, dude. Seriously, think about it. Why? Why would we do that? First picture of the far side of the moon, first animal in space? Yeah. You think we could fool them? Nah, I don't think so. That doesn't make any sense. Dude, we absolutely did, because if there was any inkling anywhere that it was a hoax, the Soviets would have been the first ones to say it. We weren't really on speaking terms in the late 60s, if you catch my drift. First functioning space station, man. The list goes on and on. Exactly, Staples. All the telemetry, all the radio signals, all the casts, you know they were watching every step of the way. Because it's not like they couldn't get stuff to the moon. They couldn't get people to the moon. That's two different things. Thanks. And now, is the Earth flat? I don't think so. I don't think so, Hannibal. So, the main argument that I have for space being real, and don't get me wrong, this isn't some regurgitated, like Neil deGrasse Tyson opinion. Let's think about it for a second. Okay, so if the Earth is flat, that means how we think about space isn't right? Like, if we're going to play off that contingency, right? Like, we're going to play off that notion. We're going to say, like, okay, you know, if Earth was flat, space doesn't exist, right? Like, space doesn't exist in the way that we understand it with orbital mechanics and spinning around planets and spinning planets and stuff like that. Okay. That's fair. Like, all right, you want to make that argument? Okay, so my argument back to that is that if space was a human construct that was invented by us, why is it such an imperfect place? Seriously. I can't prove it. I've never been to space. I can't prove that. But does a place that is entirely inhospitable to humans, constantly trying to kill you, you know, extremely difficult, extremely tough to get to, an imperfect place. There's meteorites, there's comets, there's galaxies. It's so ridiculously imperfect. No human could have thought of this. Think about it. No human could have thought of that. Dude, if we were going to think up space, it would be this gatekept thing that no one can get to. And yet something like SpaceX exists. See what I mean? They would stonewall it. The government would stonewall it from you if it didn't exist, right? No. Space is much too of an imperfect place to be thought of by humans. No. Now for the biggest question. Are we involved in satellite-to-satellite warfare against Russia and China? Yes. Sure, why not? Of course we are. But the way war is fought in space is not the way war is fought on the ground or in the air or on the sea.
Discovery, go at throttle up.
See what I mean, guys? Space is such an imperfect place. It's like it would be like a skyscraper in the middle of a forest. like, you know, a skyscraper is something that we made. You can tell we made it because it's not perfect, right? But it's definitely not naturally occurring, that's for sure. See what I mean? Really easy to spot the difference. That's my, dude, that space is such a ridiculous place. It's such a ridiculous place, and how stuff moves around through space and warping gravitational fields and stuff like that, that no human thought of that. No way. It's as imperfect as looking in a forest. There's nothing uniform about a forest. It's a forest. The only thing uniform about a forest would be a trail through a forest, in which case we made that. See what I mean? Does that make sense? If I want you to not go there to prove me wrong, I would exactly talk about an imperfect place. Yeah, Alex, but if that was the case, why would they even allow commercial ventures to go and do this? Elon Musk, Peter Beck. Why would they bother with commercial ventures? And thanks. And now is Elon Musk human? Yeah, he's human. I'm not convinced on that one. Maybe. He might be just trying to get back home. The thing about Unreal Place is that nobody can agree what they're like heaven. Bingo, Trehek. Yeah. Or a telephone tower tree in a forest. Bingo. Earth isn't even a perfect sphere. It's a gigantic jello mold. And stuff like the tides pretty much explain that the Earth is spinning like crazy and the moon's tugging on the oceans with its gravitational pull. Like, once again, imperfection. Real imperfection. Like, it's as imperfect, it's on the scale of randomness that you'd see, like, going out into nature. That's how I know it's real. Like, there's no like, like I said, if space was like perfect and, you know, you went up and the stars were all in like uniformity, then I'd be like, okay. It's random. Most things that occur in nature are pretty damn random. It lines up. But Alex, I understand, like, even at that point, Alex, you know, you said they would want it to be imperfect and they would, you know, oh, you can't go there, it'll kill you, etc., etc. But if that was the case, like I said, they would never would allowed commercial companies to take the hold that they have now. They would never would have allowed that. And all the world's governments would have had to agree to one big crazy conspiracy. Once again, why would they do that? It's not like there's governments out there that launch things into space that exactly like the US right now, you know what I'm saying? I had this thought of, what if the Earth is the only place with life on it so far and we're supposed to expand to other planets through evolution? Then we destroy the place with evolution and wars and get nowhere and all life just ends. And life never gets past level 1. Cloudy, why do you think I incessantly push spaceflight? We need to go further into space. Konstantin Tsiolkovsky, the guy that thought up basically practical rocket technology, or the math behind it, he was a Russian mathematician. He said, Earth is humanity's cradle. You got to leave the cradle sometime. That's spot on. That is spot on. You know, you got to leave your parents' house sometime. You got to grow. We got to grow as a species, man. In all fairness, Earth is actually far smoother than a billiard ball. It's not about smoothness, it's about shape. Smooth is texture. Yeah, Lazarus, there you go. See what I'm talking about, guys? There's just things that I've noticed over time, and I'm pretty damn good at noticing patterns and stuff. Like, space is a very chaotic and violent place. Why is Earth round and not a square? Well, Dev, long story short is that, so Einstein's theory of relativity, which is not a theory, they just call it a theory of relativity. It's relativity. That's the short answer. Do you actually want me to explain it? I can explain it, sure, no problem. Have you looked up this strange words that I don't understand? No, I haven't looked up that. Einstein's theory, so relativity. Yeah, that is the reason why Earth is circular. That's the reason why most celestial bodies are circular. Floating disk, I don't mind discussing conspiracy theories or even alternative theories about space. I don't mind doing that. That doesn't bother me. I don't get all bent out of shape when somebody has a different opinion about space than me, except for like maybe Eric Berger, but that's a different story. Have you seen the Rocket Lab footage? No, I haven't, Matt, but I have it teed up. Gravity has a lot to do with that. Why does gravity occur, LCD? Gravity occurs from the effects of a highly dense mass on our plane of existence, okay? So, if there's a extremely dense bit of mass going through space and time, it's going to warp said mass. That relative warp of space and time, that ripple, if you will, is gravitational pull. Gravity works in 3 dimensions. It works in all facets. So, picture if you throw a stone into a river or a lake that's perfectly crystal clear. You throw it in, it leaves ripples, right? And it'll plop in the water. That shape, but radiating out in a spherical fashion, right? You warp space and time. That warp, due to the high density, right? High density of a celestial body causes pull. That's what causes gravity. That's what causes that acceleration. Warping space and time. That's why Einstein's theory was such a big deal. And because gravity is affecting in 3 dimension, in a 3-dimensional plane, right? Because our plane of existence is in 3 dimensions, right? You're pushing at all angles from all sides. So you get a perfect sphere. Well, not a perfect sphere. It's not exactly perfect because Earth, the moon could have crashed into us, but they're pretty sure that it did because the moon is made out of very similar stuff. We know from the Apollo missions, we went there. It's very similar. It's very similar. The ore on the moon is very similar to the ore that you'd find on Earth. It's nickel, iron, stuff like that. There's actually basalt on there. There's basaltic plains on the moon, and this is getting into geology a little bit. There's basaltic plains on the moon. Basalt is something that's a byproduct of a volcano. There's no volcanoes on the moon, but there may have been at some point. Maybe an asteroid hit Earth and it splintered, right? And the moon and the Earth formed. Who knows? Or maybe the moon crashed into Earth. That would cause non-uniform density. Why do you think Earth wobbles on its axis? Because it's not a perfectly uniform sphere, but it's close. And in the center of the Earth, right, that's where the gravitational pull is the worst. That's where it's the highest, in the center of the Earth. So in there, you get insane pressure. What comes with insane pressure? Insane heat. Sometimes that, and that heats up our Earth's core, which is like iron. It's a mostly iron core, but it's basically a giant milkshake of metals and rocks and stuff. And sometimes it springs a leak. That's what a volcano is. But then you're getting into like plate tectonics and stuff, and that's what I mean. All of that is so ridiculously imperfect. There's no way somebody thought of that. It's so ridiculously imperfect. There's no rhyme or reason to it. Volcanoes can just spring up wherever. Some like with plate tectonics, some plates push up, some plates go down like this. One plate goes over another plate. Some plates just push against another plate. Like if you put your finger on a table with a tablecloth and just moved your finger, it would bunch up the tablecloth. Dude, it's so ridiculously imperfect. No one thought of that. No way. No person thought of that. Let me put it that way. Actually, the center point is not gravitational pull at all, because mass is pulling uniformly from all sides. Firework, that's I'm gonna file that in my special things that people say from time to time. Are you playing anything tonight? I might. Or it's too perfect. There's 2020, dude. You should know from your, atypical neuro, you're good at recognizing patterns, are you not? What patterns are there here? There's no patterns. It's completely random. And nature is completely random. You know what I mean? That's how I know. It's uniform, dude. That makes sense to me. Doesn't gravity pull symmetrically and or equally? I don't know, fellas. I'm not a geologist. You'd have to ask Rocket Sage. You're completely random. Got him. Yeah. The ideal ratio is fairly common. Yeah, but the ideal ratio in itself is a human construct. There's no ideal ratio like that. That's our interpretation of nature. Would you ever be interested in astrophysics? What do you mean astrophysics, Smoked Balloon? Having viewed multiple objects with a telescope, it's very random. Dude, that's always been my thing. Like, and don't get me wrong, fellas, people are always going to be skeptical. That's fine. I'm not going to get annoyed at people that disagree with me or space or whatever. Like, dude, because you being a prick to these people that are skeptical is going to change their mind, right? No. That's going to make it worse. You know what I'm talking about? The only consistency is inconsistency. Bingo. It's totally random. There's no rhyme or reason to it. Space is a terrible place. It can kill you instantly. It's always trying to freaking kill you. That is exactly like Earth. Earth is exactly like that until we figured out a way to not have it do that. See what I mean? Just playing devil's advocate, Fibonacci sequences. I mean, I guess, yeah. I mean, because we're all in a construct on this plane of existence, there's going to be certain patterns in certain spots in certain areas, but there's no... Like, there's some correlation because, it's like looking at, like, okay, think about it like this. Okay, my pickup truck, right? It's an F-250. It has a Ford logo on it. My 59 Ford also has a Ford logo on it. Are they the same truck? Are they even remotely the same? Were they even made in the same factory? No, but it still says Ford. There's a pattern right there. There's a pattern, but that pattern has no correlation on the vehicle that it's on. They were completely different engineered vehicles, engineered at completely different times. By actually about 40, 50 years difference, but you get what I'm saying. Sorry, I wasn't being sarcastic. No, I know. But yeah, hopefully that helps, guys. Like, if you're skeptical about space, like, you want to ask me a question, I won't, I'll ask, are you trolling or not? If you're trolling, I don't care. I get asked that all the time. That's fine. But if you generally want to know, I'm not going to sit here and say I'm going to change people's minds about it, but I have some pretty damning things here and there. Like what I just told you. You know what I mean? Why haven't we found anything unearthly yet? The moon is made of rocks we know of. Planets are made of gases we're familiar with. Because the real answer to that is that the universe is so ridiculously big, you got to go a little bit further. That's like walking around Alaska and saying, why haven't I seen a palm tree yet? These trees are all the same. I've been walking around forever. Alaska's huge. These trees are all the same. Nope. There's no other types of trees. Does that make sense, dudes? Like, I'm not trying, like, that's the other thing that's the other thing I do when I come into contact with skeptics, dudes. I don't try to change your mind. I'll just tell you some things that I thought about. And it's my thoughts. They're not anybody's thoughts. I'm not regurgitating anybody's opinion. I can think for myself. Dado, the universe is freaking huge, man. There's all kinds of stuff out there. New elements are being synthesized and discovered all the time. These elements could occur naturally in the universe. It's possible. Any Bob Lazar fans out there? Yeah, I know about that too. Any Bob Lazar fans out there? I love Bob Lazar. That's amazing. Bob Lazar, the Pokemon? Yes, yes. James Webb is the closest thing to solving that issue. There you go. I mean, he could be full of crap, to be fair. I don't know either way. But he is right about new elements being found. That is absolutely correct. Well, Bill, that's my approach. You know, anybody can just go Google anything. I like to think that the people that say, "Oh, how do we know this?" haven't either A, don't believe Google, or B, don't care. And that's what I mean about trolling. You trolling me? You know. That's why I never, you know, if somebody asks me, that's why I said when Hannibal asked me just a second ago, he's probably not even here, he's probably gone. Look, I can give you some damning proof. I'm pretty dang sure, like, that makes sense, you know, but I don't know, man. If I gave another explanation about an imperfect Earth, and Alex in chat said, yeah, but you know, they would say that they don't want you going there because it's dangerous for you. Yeah, that's fair. That's fair. It's not like damning end all be all proof, but it's just stuff to ponder. If we can fake it on Earth, that doesn't mean it can't exist elsewhere. Bingo. What are your thoughts on the movie The Martian? Smoked, I like The Martian. The book's better. Read the book. The book gets into some real nerd stuff. I really appreciate it. All new elements are too heavy to be stable, so they will not occur naturally. Can you say that with reasonable certainty, Bobo? Honest question. I don't know enough about it.
Discovery, go at throttle up.
You may want to check anthropic principle. All right. Sure. Or you could just, tell me what it is. Hey, Novaraptor, 5-month resub. Yeah. But the best part about that guy that made his own rocket and launched himself on it was that his family straight up, after he passed Mad Mike Hughes, respect. After he passed, his family straight up said, yeah, we just used that as the way to get money. Mike Hughes was more of Evel Knievel, less crazy person, which is hilarious to me. Hey, you're back from the garage. What's up, Crumpet? He was a character. That guy's my hero. I really wish he just said that to begin with, but then again, yeah. It was awesome, Noswolf. We know about... Okay, Novaraptor, what do you got for me? You got a rocket question. We know about Artemis 1's engine bleed. Do LR-87s do something similar? LR-87, so Titan. The Titan motor. It depends, actually. What vehicle is it attached to? It depends. If you really want to know. Not entirely confident in my understanding in it, but TLDR, the universe being good enough to make us exist doesn't mean it can only be that way, if that makes sense. Yeah, floating, that's what I'm trying to say. It's the Alaska palm trees theory. You know what's really going to knock your socks off? At one point, Alaska was a tropical climate. That's really going to screw with people. Yeah. Think about it. They find dinosaur bones in Montana all the time. Picture Jurassic Park in your head. What environment does the dinosaur exist in? What's in the background? Oak trees? Mountains? Yeah, there's mountains. There's volcanoes too, isn't there? And there's palm trees everywhere. And they find these dinosaur bones in Montana. Oh yeah. Crazy, right? Which movie? Don't worry about it. So, yeah, Novaraptor, you had a question about LR-87s and bleed down. What rocket? It depends, because the LR-87 is one of the only rocket engines that's been able to use hydrolocks, carolocks, and hypergalls. Yeah. Hypergalls. You don't need to... Bleeding with hypergalls is just a matter of pressurization. That's it. Just a butterfly valve that opens. That's all. Yeah, Smoked. Dude, the land that you're standing on moves around. It moves around. It was one big supercontinent at one point, and then plate tectonics, that imperfection that I'm telling you about, literally ripped continents apart. In fact, you really want me to blow your mind? That's happened 3 times in Earth's existence. The continents spread out, and then they come back. Earth contracts and expands. It's friggin' wild stuff, man. How does bleeding work? Smoke to balloon bleeding? Okay. Example. This is gonna sound stupid, but I assure you, I'm not trying to be a dick. You ever use a garden hose before? Ever use a garden hose? I'm serious. Just like the garden hose. You go to the side of your house. Turn the thing. You turn the thing. What happens? Yeah, Astro. I hope we're not around to see that. That would be very bad. Water comes out. Yeah, Nova. Water comes out. Is that it? Does water come out right away? Think about it. Does water come out right away? You have the hose going out to a sprinkler, right? And you want to water your lawn. You turn the hose on. Does the sprinkler turn on right away? What does it do? Air rushes out before the water. You're evacuating the gas and you're replacing it with liquid. And then you build up the pressure and then the sprinkler turns on. Literally that. But the gas, instead of being nitrogen and oxygen, atmosphere, is gaseous hydrogen in the case of the shuttle engines. It's literally the same thing. But you got to remember, hydrogen is a liquid at minus 420 Fahrenheit. Yes, I'm saying it that way so I can say the number, okay? It's 271 C? Minus 271 C. Okay? Like 5 Kelvin or something like that for the people that like Kelvin. Kelvin's the best. Kelvin's the best. Screw centigrade, screw Fahrenheit. Kelvin's where it should be. Kelvin's where it's at. Anyway, scientists are like, yeah! Anyway, so hydrogen exists as a liquid. You can't just turn the hose on because what's going to happen? That hose will freeze. It'll freeze instantly. That's called thermally shocking something. You'll get thermal shock if you stand behind a jet engine, for instance. If the pressure doesn't get you. A lot of temperature change is being introduced very fast. That's a thermal shock. That can cause things to crack. Because what happens? What happens when something freezes? Or what happens when something heats up? It expands and contracts. You contract with the cold. You expand with the warm. The one exception to that is water. Water literally does the opposite of that, which is weird. But water is weird in itself if you think about it. Where's my Rankin nerds at? Hell yeah. Australia's moving 2.7 inches north every year. They have to keep updating their GPS because of it. Bingo. South America is moving west, believe it or not. Eventually, it'll just shear off Panama. That's in a couple million years, though, but it will happen. That's right, MotoKid. Yep, still on the table. So, going back to the garden hose, if you froze that garden hose instantly, it'll freeze, and it'll contract so quickly that it'll fracture. That's engine bleed. They don't want it to crack. That would be bad. In the particular case of Artemis 1, it'll spin the bearing when they try to start it up if there's gaseous hydrogen in the line. Because if there's gas flowing over the bearing, that means the bearing isn't cool enough. Right? Does that make sense? And that's why they said hell no. We're not flying this until we verify that the sensor is not giving us a right reading. I'd love to see the whiteboard that EJ most likely has above his monitor. I don't have a whiteboard, dude. All of this, I assure you, is off the top of my head. And dude, if I had a whiteboard, that'd be pretty pathetic because I get a lot of things wrong. Did the F1 or the J2 experience engine bleed? Nova, you tell me. I don't like to answer questions with questions, so let's think about it for a second. Okay, F1, it uses kerosene. Does kerosene, if you flow it through a pipe, make gas? Does it turn to gas if you throw it through a pipe? No. So that's not a problem. Bleeding the F1 engine with kerosene is no problem. That's fine. Easy. Just literally open up the pre-valves and let gravity do its thing, right? What about the LOX, though? Unless you burn it. If you burn it, it turns to gas really, really quickly, Ubiquitous. Yes, you're absolutely right. No, Colonel Sanders, you're wrong. Mama's right. So what about LOX? By the way, the Earth is not expanding and contracting. Yeah, Aqualex. It's called hyperbole. Yeah, I know. You need to, sometimes you take what I say literally. It's hyperbole. It's just, when I meant expanding and contracting, I didn't mean the physical shape. The continents are moving around. The continents are expanding and contracting. Sorry, it's just, I didn't say that exactly right. Sorry, I didn't have my whiteboard ready. So what about the LOX, Nova Raptor? Do you have, if you're bleeding LOX, do you have to make sure the gas is evac? Oh yeah. See, with LOX, guys, it's a little bit different. With LOX, you can have anti-geysering, okay? Or you can have geysering. What's geysering? Okay. When you're flowing liquid oxygen, and don't get me wrong, flowing liquid methane and liquid hydrogen is the most, that's like what you really got to be careful, okay? So if you're flowing liquid oxygen into a rocket, you still have to go slow to thermally condition the pipe. But with LOX, you have to, it's not like you have a high flow rate and a slow flow rate. Like, it's not as defined as it is with hydrogen. You start slow filling and then it does get a little bit faster. Actually, you basically do. The reason why I said it's kind of different is because SpaceX does the loading just in a little different way because of densified propellants, but it's pretty much the same idea. With LOX, you have to bleed the lines, but you don't necessarily have to worry about LOX leaking out of flanges and having catch cans in the system, Nova Raptor. You don't have to worry about that. What you have to worry about with LOX is geysering. So the gaseous liquid oxygen in the line won't leak out of anything. Geysering will happen if it pressurizes inside of the line. If the gaseous oxygen pressurizes inside of the line, you could blow the line. That's why when SpaceX fills up Falcon 9, right? If we watch like a whole thing of them filling up a Falcon 9, like where we get to see the fueling procedure, like when they launch people into space, right? They chill down the strongback. They do a strongback chill. The strongback's fuel lines are full of nitrogen, and they get the nitrogen gas out, and they replace it with liquid oxygen. They open up the vent at the top, so when the LOX is filling it up, right, you don't get pressurization inside of the line. Now, don't get me wrong, you could geyser with hydrogen too. It would be a lot, it's not as, hydrogen will just leak. It'll just leak before it geysers. Methane though, yeah, probably. Whiteboard behind the green screen when? I'm working on it. I was just screwing with you. Your engineering launch is very quick. I couldn't do that on stream. yeah, I know, Celtic, I know. But I'm in like super serious mode, dude, so you're gonna have to bear with me. Yeah, floating. Yeah, good stuff. So Nova Raptor, yeah, with an F1 J2, yeah, you'd have to be careful with that. Now think about this for a second. I'll kind of take your question into a kind of provocative area. Saturn V. Think about this for a second. Do you start? Do they thermally condition the engines for the second stage? The J2s. They do thermally condition them. They chill them down. Did they do that on the pad? Why? Why wouldn't they do that on the pad? that's right or not. Why wouldn't you do that on the launch? Why wouldn't you thermally condition your second stage engine on the launch pad? So it wouldn't explode. Why would it explode? You're just thermally conditioning it. What if all black holes just end up as one certain atom before ending? Cloudy, I don't know what's at the end of a black hole, and I don't want to be there to see it. I'll be honest with you, man. Waste of fuel? Why is it a waste of fuel? If you chill them down on the pad 2020, if you chill them down on the pad, then you can use topping. So if anything, you'll prime the entire system. And then you can cut the fuel lines when the rocket launches, and it just stays in there on the way up. Why wouldn't you do that? Why would you chill the engines in flight? You'd blow a head gasket, Hellfish, or you'd seal a piston ring if you tried to put locks into a car. It makes venting the interstage easier. Pressure in the interstage. Maybe. What about Falcon 9? Falcon 9 chills on the way up. It's performance, guys. And the other thing, this is another thing. This is, and once again, this is why this is a provocative thing and not necessarily. I wasn't expecting people to get the answer here. LOX makes things corrosive. It rusts things very, very, very quickly. LOX is very corrosive. Very corrosive. Like burn through a metal table corrosive in like a day or two. Can we try a lawnmower or other single cylinder for science? You want me to put locks in a lawnmower? Dude, you'd probably freeze the carburetor jet. When you're super serious mode, it made me think. And the fact of preconditioning is crap, something I never considered. The entire fitting process and what you see leaking just took on whole new terms for me. Mm-hmm. You'll send a piston into orbit. Noswolf, it's a really good way to visit Rodney. Do you know visiting Rodney? Visiting Rodney in the context of cars is not a good thing. You don't want to visit Rodney. That's bad. Is LOX corrosiveness the reason why the RS-25s couldn't be rapidly turned around? No. Not necessarily, Novaraptor. No, it's not. I can prove that. Who knows what I'm going to prove it with? Your whiteboard? Damn it, how'd you know? Check this out. Aerojet Rocketdyne did this back in 2018, Novaraptor. Look at this. Aerojet Rocketdyne demonstrates 24-hour turnaround of AR-22 engine for experimental spaceplane concept. An AR-22 is just another name for a space shuttle main engine. They put a space shuttle main engine on the pad, on the A2 test stand at Stennis and fired it 10 times in 10 days. Now, to show that it could be done, to show that they could rapidly reuse a shuttle engine. They did it in 2018, and it really pissed me off because that proves that mostly proves that shuttle engines could be rapidly reused. It's just that the safest way to do it is to rebuild it every time. Now, two things about that AR-22 test. They weren't firing it for an 8-minute duration. They were only firing it for like a 5-minute duration. Yes, that's a big difference. That's a long time. So that may have been the reason why. The second thing is that RS-25s, space shuttle main engines, AR-22s, they do need to be dried after testing. Absolutely. You absolutely have to evac the LOX out of there. They use a dehumidifier to do it, to get all the LOX out of there, and they purge it with nitrogen. Helium, not nitrogen. Nitrogen's ground side. No, Fauci, I haven't shown it yet. Do for a cigaroo. Seek the maker. Everyone's laughing at you. The world's not a globe. We are not minuscule specks in a never-ending universe. You can and won't find what you do not look for. God, waiting for you, loves you. Hey, you know, whatever. I mean, you can say that. I don't really care. What if the maker made the universe? Then what? Then what? Now what? Now what do we do? Honest question. Random question, since we haven't done Minecraft in a good while, and Artemis 1 is happening Saturday. Can we do Minecraft tomorrow? Server needs a bit of a jump start. Oh, yeah, I didn't really think of that. Yeah, sure, why not? I don't see why not. We can play for early hours, yeah. TLDR, the Artemis 1 scrub in current status. Goon, NASA proved that developmental sensor, which is not required for flight, it's just additional sensors for additional data because it's a test flight. It is malfunctioning in some way, shape, or form. It is not required for flight operations, and NASA proved with the data that it is in fact malfunctioning. Funny story. Personal thing. Personal opinion. I honestly think it's not even the sensor. If I had to guess, it's the connection to the sensor. And NASA specifically, they hinted at it, but they never said it. Okay, here's why I think this. In cars, with a car, like a regular car, all right? How many times you taken it to the shop because the check engine light is on, and it's not even a bad sensor, it's the connection to the sensor. Just the connection came undone. Because it's a car, you're driving around, it's bumping over roads, connectors can come undone. Or it's giving you a bad reading. Think about it. See what I'm talking about? The way that NASA explained it, they said that the sensor was in family until they got to, until they really started to get down to the end points of bleeding. So when it got around minus 390 Fahrenheit, that's when it started reading incorrectly. Dude, that's a bad connection through and through. Oh yeah, sensors don't really malfunction. It's usually something else. Sensors do break, but they don't halfway work. If a sensor breaks, it breaks. It stops working. But it doesn't halfway work. You know what I mean? That personal opinion, the connection to that DFI sensor, either somebody hit it or it was rolling to the pad and it came undone. See you last. Shadow Rogue, what's up, dude? Hey, not sure if you heard about this yet, but a spaceport just got greenlit for construction in your province of Canada. Oh, that's great there, bud. You're Nova Scotia, right? Oh yeah, the one that's up in Nova Scotia. Oh yeah, that's the launch complex you're talking about, right? Hell yeah, man. That's freaking sweet, dude. Dude, I'll be able to see that from here. I don't know, maybe 200-300 miles, Shadow Rogue, or, well, what's 200-300 miles? About 400 kilometers southwest of you, give or take.
Go and throttle up.
Out on a peninsula. I should be able to see it go up if you guys launch something, which would be pretty sweet. That's cool, man. Yep, I've never seen sensors read wrong because the sensor itself was bad. It's always all or nothing. Yeah, and don't get me wrong, Elvis, we're comparing car sensors to rocket sensors, but that sounds like the connection to the sensor is bad, but NASA wouldn't get into that detail, but they hinted at it. John Blevins hinted at it. It sounds like the connection to the sensor is bad, but I don't know. That's just personal opinion. Either way, they're good to go. They are good to go for Saturday. Yeah. They fixed the catch can problems. The catch can problems are well understood. The interstage vent is well understood. And they did confirm that they were getting quality hydrogen to all 4 engines. The chill down basically worked. They could have launched SLS, but they weren't sure. And you don't want to launch it if you're not sure. You know what I mean? Since I'm on engine reuse, why would SpaceX develop a full flow stage combustion engine? Surely an open cycle would be easier to maintain, as proven with the Merlin. It's the requirements for the vehicle, Nova Raptor. Stakeholder requirements. You need an engine that powerful to be able to make something like Starship that powerful. Yeah, it's not like they developed the engine and said, okay, let's build a vehicle off of this. With that full flow stage combustion cycle, they went for broke with propulsion because of Starship's requirements for basically it stems from Elon's Mars Colonial Transporter requirements. He's the chief engineer, remember. And at the end of the day, what do I always say about engineering? Every time. What do I say about engineering? It's always what the stakeholder wants, not shareholder. That's different. In some cases, the stakeholder and the shareholder can be the same thing if it's a private company, right? Engineering is about stakeholder expectations. What are you trying to do? And the requirements for building a vehicle that big would constitute a full flow stage combustion cycle. Does that make sense? Connector? I barely knew her. You sense that it's the sensor. Upstate, you might have a bad sensor. Hey, Linux, thanks for the raid. Cletus forgot to use the good dielectric grease when he installed the sensor. Fig Vaseline will do. Probably. Sensor could be borderline out of calibration in such a way that it's undetectable at normal ranges. But as you go to the extremes that error compounds, I've had to deal with this with the 3D printers you've run at work. Yeah. Okay, Aqualex, let me answer. Let me ask you a question. If you had 4 3D printers all with the same sensor, the same exact sensor, and one of them was giving you a weird reading, would you think it's the sensor itself? You calibrated all 4 of these things. Did you make a mistake? Now, don't get me wrong. Range sensors on a 3D printer, right? That's a little bit of a different thing. That is a mechanical sensor, not a temperature sensor. I understand calibration on 3D printers, dude. I have 2 Ender 3s sitting in my garage. But if the other 3 sensors on the other 3 shuttle engines are working correctly, I'm inclined to believe it's connection. If the other sensors were doing that, because they were all most likely calibrated at the exact same time, if the other 3 sensors were doing that on the other 3 engines, I would be like, yeah, you're probably right. It's probably a bad sensor. That's why I think it's a connection, because the other sensors didn't do anything. Do you want steak? Because I want some now. Yeah, maybe. Yep, plus with methane you can make it on Mars so a crew could get back. Yeah, Nova, that's the other thing. If you're going to go full cryogenics to be able to make your fuel on Mars, you might as well do it. And the vehicle already requires it. Linux, thank you for the raid. I'll fire up the grill. Good man. Goalie, quick TLDR. SLS is good to go Saturday at 2 o'clock. Fueling will start at 6. Methane also cokes less. That's correct. Yep. Yep, better for reuse. Yeah, decoking and engine core space. Tell these fools about how much of a pain in the butt that is. I've talked to guys that work at McGregor. Decoking the engine is a pain in the butt. Residue gets everywhere with Carolox. Everywhere. It's like, yeah, no, it's bad. I cannot wait for Artemis 1. I've been waiting for this since high school. I've been waiting for a long time as well, Nova. Yep. So how'd we get a Saturday launch when the backup dates were Friday and Monday anyways? Yarg, they always could launch on Saturday. NASA PAO done goofed? Maybe? Did you get some sleep? Yeah, I'm good, nerd. Yeah. I got a good 8 hours of sleep last night. I slept great because I did really well in F1 Manager. That made me really happy seeing Haas win like that. Not win the race. 5-6. I'll be in it for a long haul. Maybe I can watch from a plane. Yep. Anyway. Yarg, Colin's sick. I'm serious. Colin's sick. Say your cat has to go to the vet or something, dude. I don't know. You don't want to miss this. I may have misheard, but during the presser they said if the same sensor issue pops up, they'll try for a launch regardless. Yeah, MotoKid. Mm-hmm. Yeah, the DF... Okay. We got... What was the analogy for this that we came up with? Okay, Shaw. You know what an OBD2 sensor is? The presser was a little confusing, to be honest. Guys, this is... Yeah. Ask me. I got most of the information, pretty sure. So Shaw... Or, no, not Shaw. MotoKid, excuse me. I think Shaw asked the question before you, but that's okay. MotoKid did, yeah, GPS in the back seat. That's it. Yeah. So, I'll explain what NASA said, and then I'll give you an analogy for it. Okay? So, the sensor that was reading out of family, okay? The sensor that wasn't reading correctly is a developmental flight instrumentation grade sensor. So, DFI, okay? On spacecrafts, you have different kinds of sensors. There's OFI sensors and DFI sensors. The operational flight instrumentation sensors, or OFIs, those are the ones that you're using. Okay? Those are the ones that are connected to the flight computer that the flight computer is going to use to verify that the vehicle is good when you go for auto sequence or start, right? The developmental flight instrumentation sensors are a sensor that is not tied to the main avionics of the system, but it's designed, it's attached into a developmental flight recorder. Basically a black box for the rocket. But there's not really a black box on a rocket. Rockets are actually designed to, and this is a really cool networking thing if people are into this. Rockets are designed to offload insane amounts of data in like 8 minutes, almost in real time. Like, they're doing the entirety of the 8 minute ascent. The 8 minute ascent is being downlinked and recorded in the launch control center and the flight control center in real time. That is an insane amount of bandwidth. An insane amount of bandwidth is needed for that, and an insane amount of data, like terabytes of data in minutes. Hey, Wood converted a Prime sub to a Tier 1 sub. Thank you. Interesting, Aquash, yeah. And folks wonder why we don't get more video footage. Yeah, MotoKid. SpaceX gives us live views all the time, every launch. We get a live high-def view of Falcon 9 launch. This is why I always say this never gets old, and we're getting spoiled, because the tech involved here is absurd. Yeah. Where can I go to watch SLS that won't already be overcrowded? I'm within driving distance. Are you fathered by any places of worship, private organizations, or ex-military, if you don't mind me asking? No, Sigaru, I'm just a nerd, dude. Just a nerd. I'm a 3D artist by trade, but no, just a nerd. I don't know, man. You're not gonna find, dude. Everywhere is gonna be crowded, so just pick somewhere. That's what he wants us to think. You think, Jason? You think I'm a spook? Think I'm CIA? That'd be cool, but no, I'm just a nerd. Church of Blender, perhaps? No. I glow in the dark. Oh gosh. I'm glowing because of my lighting setup. Wait a minute. Yeah, that's what a spook would say. Oh gosh. No. I know people in the Department of Defense. Does that help? And a lot of ex-military hangs around in the stream. No, I'm just a nerd. The reason why my hair is like this is because I don't Yeah. It's a pain in the butt trying to keep it all organized, so I just get rid of it. Aqualix like, hey. We seen my shoes? Definitely not a Fed. Fair enough. Oh, good. Yeah, Faulty. I don't know. I don't know what you're gonna find, dude. Titusville maybe, but dude, it's gonna be jammed. They said that for Artemis 1, like 500,000 people showed up. EJ is the anonymous source. Yeah, I have a high and tight military style haircut. Not because I'm like, dude, you know those people that have like never served that are like, yeah, military. Dude, nope, definitely not one of those people. I like this because it's low maintenance. It's really easy. There will be more on Saturday, Hellfish. I agree. Turn us away. Yeah, Snibbles. There you go. Only saving grace that it's not the original day. Everywhere is going to be crowded. Yep. Greg's like, I'm ex-defense. I did 15 years in the Aussie Army. I'm on a pension because your back's buggered. Yep. I have a bunker full of freeze-fried meals, 50 guns, and 500,000 rounds of ammunition. Dude, chaotic. You know what? I'm not a prepper. But that's kind of cool. Like, oh, damn. There, I said it. I said it. That's kind of cool. You don't want a bunker with, like the one from Terminator 2? You know, when they're like, Enrique, that's okay. They open up the freaking thing. There's just a freaking arsenal that, like, you don't want that? I'm like, okay. Okay. I kind of, yeah, I get it. All right, I got you. You know? Like, I'm like, nope, all right, yeah, that's kind of cool. Okay, all right. Yeah, like Colin Furs, exactly, man. At least you wouldn't show up here. Oh, God, Aqualexa. Dude, I don't want to cringe. Bunker under the garage confirmed. Yeah, I have. Yeah, Hellfish. I get a lot of canned goods, but I have canned goods not because I like prepping. I get canned goods because canned goods are easy and they don't cost a lot, and you can, and because of that, you always have food in the house. You have to literally make less trips to the grocery store. Like, that's just being smart. That's not prepping or anything. You know what I'm saying? Like, I don't want to go to the grocery store as much, man. So I buy more canned goods. Have you thought of getting solar panels? Yeah, Mycon, actually. Or being lazy. No. If I'm going to go to the grocery store, might as well get more because then you don't have to go to the grocery store as much. Like, that's not lazy. I mean, it kind of is. You know? Also, having a standard kit of food in the house means you're ready to make a wide variety of meals. Oh, God, you got me figured out. Yeah, frozen is better, Chaotic, but if you lose power, frozen gets to be a little tricky. Canned does not. The only canned goods I like is beer. Ah, Greg, you're over there drinking VB, aren't you? Don't lie. Get a freezer and you can buy meat in bulk. Yeah. True that. We don't have a freezer, Gaw. I'll fix that, though. Actually, I do have... There's a fridge in the basement. It's not a meat freezer, but I know what you mean. I always keep canned basics for at least stew or pasta sauce. Freeze the meat bits. 30-minute cook time and a decent meal. Bingo. Stock on maple syrup, non-perishable and nutritious, eh? Nice try, Doug McKenzie. No way, man. It tastes like cat piss. I know. I've never had it, Greg, but it sounds like the PBR of Australian beers. 2020, what's up, man? Oh, boy. I'll help out with electrical in a bunker if you build one. I don't want to build a bunker. Hey, Ensign, what's going on? I don't want to build that. I mean, I do. I do because it would be cool. Colin First style, not because I'm some crazy doomsday person. Okay, maybe a little bit. Okay, maybe a little bit. Are we building a bunker now? No! No! Yeah, Aqualex, for sure. Yeah, a meat freezer. Yep, yep. EJ and Colin Furs collab. Oh, I wish, man. That would be cool. Would you stream building a bunker? No. Meh. See, what's the purpose? What's the purpose of building? If I'm building a bunker prep style, I'm not telling anybody about it. I'm telling no one. No one needs to know. You know what I'm saying? Because if I'm building it for prepping, that means the poop hit the fan. I don't need people knowing that I have a secure facility on the premises. That would be stupid. In case the feds start snooping in, yeah. Not even Bremo? Yard, you alright? Secret literal man cave. But if we're building a bunker to be cool, yeah, I'd stream it. That'd be cool. But guys, like, really, I can't. And it's not to say that I can't. So, like, the house has a grass field behind it, and then there's trees, and then the garage, right? Like, the garage is a good ways away. And I'll tell you this. When I dug out and put the internet in, I had to, like, kind of go around the trees, right? And where I'd want to build a bunker, I would either A, have to remove a ton of trees, or B, I would have to put it where the internet is. But the thing is that that's where my septic tank leach field is. So, yeah, you don't want to make a bunker there. That would be pretty crappy. Go deeper than my septic tank. Corny joke. Oh, you piece of crap. That'd be pretty crappy. I can't do it. Convert the septic tank into a bunker? No, I don't want to do that at all. I don't want to do that at all. It's got the juices.
Discovery, go at throttle.
What, my septic tank leach field? Yes, that does have the juices in it. Can we wipe that joke off stream? Go deeper, you can easily go 60 plus feet with standard wood collar. I don't want to build something underneath a septic tank. In space terms, that's called a wet workshop. Who's going to look for a bunker in a leach field, though? It's genius. Oh, God. Can we go back to talking about space, please? Please? Oh, God. If you're gonna wipe that joke away, you got to use double ply. I can't because I have a septic tank. Oh, we've been over this. Here, chat. Don't make me jingle the keys in front of you. God, you're on fire tonight. Oh, I don't know why. Don't dig too far down in Mass. That's where they put the highways. Yeah, that's only in the city though. Always lower the septic tank. Yeah, Hellfish. For that amount of money, dude. Oh, man. Cajun, what was your last? I don't see it. There's a lot of people talking to me. My entire chat is highlighted red. Okay, but hear me out. You could probably hit bedrock pretty quickly and crack it pretty easily. You could literally get several blasting compounds without permitting thanks to being binary in nature. I don't want to do that. You see Sturo today? How many trucks, Jensen? Just say, how many trucks? Like a little bag of poop on your doorstep. You're on fire. It's that poop again. I stepped away. Leach field set up for a bunker? Just ban that. Yeah, I don't think people here know what a leach field does for a septic tank. I don't. You can go look that up on your own time. Nice. It's, what is it, Cambridge Christmas, Jensen, right? Don't put it out with your boots, Tad. Don't tell me my business, devil chat. Call the fire department. This one's out of control! Do you like it? Did that get your attention? Oh, dude, the entire top of that U-Haul is gone. Eee, that's nice. Show us your leach field. I don't want to do that. You said keys? Gotta see whose engine it is? Me after Taco Bell. God damn it. You and your damn Zoomer memes. Why are they so funny? They're not supposed to be funny. Now put that over the leach field? Will there be a leach field left, Cajun? Wrong toilet paper can clog your system. Oh, believe me, I know. Yeah, I got a lecture on that. Joe, I know about the Tejas, man. This is Astra. They're testing a new engine here. That one seemed to have worked pretty well. Yeah, Celtic, I don't think people understand what a leach field is. That engine's not at full throttle. We have overexpansion there. See how the flames go out and then they go up? They should go out right there. That thing isn't at full throttle. She's in dry dock? Cool, I can't stop laughing. It hurts so bad. Sorry. What in the world did I just walk into? Yep, this is definitely a rocket engine. You can tell it's a rocket engine because of the way it is. And guys, for the, you know, for the real nerds, let me tell you. This is really hot. Not here or here so much, but it's really hot like right in this area here. See that? See that? Really hot right there. So it's Saturday. They moved it to Saturday. Saturday at 2 p.m. Eastern. See that? It's really hot like right here. Not here or here so much, but right there. It's hot. Let's start melting, ladies, because the rocket engine's hotter than hot. It's hot, hot, hot! Ah, that hot. Yeah, so that's Astra. They're testing a new engine. They're Reaver-derived engines built in-house by Astra. Cool. Cool. Did it go engine rich at the end? Sometimes that happens, 2020, yeah. Let me watch the shutdown, okay? So where would you need to put your steak? Honestly, Poker Bacon, you could put your steak over the gas generator output, and it would cook it just fine. You put it in front of the rocket engine, there wouldn't be any steak left. Anything that's like right in this area right here, you're not getting back. Astra backed out of a NASA contract to focus all efforts onto developing a new launch vehicle. Yeah, that's right. Let me watch it throttle down. Why not on the nozzle? I mean, Chaotic, you could put it there if you like your steak well done. But if you like your steak well done, I'm going to ask you politely but firmly to leave. The gas generator, the gas generator exit would be, that'd be good enough. That'd be good enough. Yeah, it'd be good. It might be a little carbony, it might be a little sooty, like cooking on a charcoal grill, because that's basically what that is. I mean, honestly, Chaotic, you could literally put a griddle. Put a griddle down here, bolt it to the ground, and then find a way to keep the steak on it, and it would cook it right there. It would cook it like a convection oven. It would broil it like a convection oven. Oh yeah. That's how much heat we're talking about. You'd be tasting the heat, not the meat. Coal Road steak, got it, yep. The steak may as well become charcoal. Yeah, no. If you could put it on a griddle, like right there, and find a way to just have the heat there and not the wind that comes with it, so like keeping the steak on said griddle. Oh yeah, you don't even need to turn the griddle on. The convection heat from the rocket engine will cook your steak and the griddle probably. Yeah. Rockets are pretty sweet. Really cool way to cook steak. That'd be a really cool thing for a restaurant. Yep, here's the test cell. We're testing a rocket engine today. You can't stand near it, but your steak is right there. Here's your steak. I think the rocket company should incorporate steak tests for temperature measurement. Yeah, but what if you have a bad steak sensor? What if it's out of family steak? How many degrees would that be on the steak? Like I said, broiling. Rocket cooked steak that have been tenderized via explosives. Vaporized steak coming up. ARJ, 57 months. All right, 2020, let's see the shutdown here. Let me watch it again. So you're talking about that? I'm not 100% sure because I'm not too familiar with the Reaver's plumbing. It looks like an open cycle gas generator with film cooling. A little further. Oh. Sent me a thing? Alright, Mutter, what's up? Insta shows a couple of different angles. Oh, sweet. Yeah, green is not... Green at ignition is okay, fellas. Green not at ignition is not good. So... Yeah, that's very green. Okay, so... Huh. Interesting. So, okay, I can see the chain of events happening here, but I'm not going to sit here and say like I know this engine like the back of my hand. But normal Reaver is a tap-off cycle, not open cycle. Okay. So green on engine shutdown means copper. That copper burns green like that. Triethyl aluminum and triethyl borane, pyrophoric ignition fluid. Yeah, igniter fluid. Yeah, I know. Blinker fluid. No, that would give a green flash on ignition. I didn't really see that there. But let me... Yeah, they didn't really show the engine turn on. It's already flaming. So, if you see it on engine shutdown, like the very distinctly green... Whoa. Okay, so that means that you're burning the inside of the engine. That means the engine's getting too hot. But, here's the thing. It didn't shoot out green flames during ignition, okay? So, that's healthy. That is healthy for a Kerolox motor. Kerosene and liquid oxygen. It's basically rolling coal. Yeah. They run really fuel rich for temperature purposes, but there's a hint there. So, with this sequenced ignition, it seems like they may have cut one of the valves too early on the engine. But then again, I don't know too much about this. You'd have to ask Rocket Guy about this. Saturday, Nikkei. That's exactly what happened, Aqualux. Yeah. So, you see the engine right here? It blows out a lot of unburnt fuel during shutdown. See it right there? That's a lot of unburnt fuel. The flames change color. Just like on an engine, on a car engine, you could tell how the engine's running from the spark plugs. You can tell how good an engine is running a rocket engine is running by looking at the flames. That's a really easy way to tell. That engine's nice and healthy right there. That's all good. It's working just fine. Everything is working very well. They definitely are doing some kind of either combustion chamber or film cooling there. Combustion chamber or throat film cooling. That's what these flames are. But see the color of the flames? Nice and uniform. It's all one uniform color. That means it's coming out at the same temperature and it's coming out at a very nice uniform velocity. That's really good. That's good. That's healthy. So what happens here, they initiate the engine shutdown, okay? And right there is where the turbo pump shut off. So you could tell the turbo pump shut off because the gas generator is off. They shut it off. You see how the plume that's coming out of there is kind of disrupted? So when they shut it off, it seems like rocket engines, when they shut down, I'll use the garden hose analogy again, or like if you shut off you have a garden hose that's attached to a sprinkler, you shut the sprinkler off, right? The sprinkler will turn off, right? Does that mean there isn't water in the hose? No, of course. There's always residuals. It looks here, whatever happened during shutdown, that there was more residual liquid oxygen, or more residual liquid oxygen than there was kerosene. You could see unburnt kerosene being shot out the sides of the rocket engine here. Now, it's important to note that that is just literally on the sides here, which is weird. That could just be how they're film cooling the engine. But see the change of color? Change in color, change in temperature, right? This goes from being white hot over here down to like an orangey color. Orangey sooty flames here indicate fuel rich, so it indicates a lower temperature. And then, yep, you get a little bit of residual. You get a little bit of residual. That's the residual propellants combusting inside of the engine. That does happen. That happens with most rocket engines. And then you see the green flames. So it seems like during the residual combustion, this does happen. During that residual combustion, it definitely went a little bit oxidizer rich, and it burned off some of the engine. These green flames are coming from literally ablating the inside of the engine. And they could have copper cooling channels, and if it has copper cooling channels, copper burns green. Like that color, like neon green. Copper burns exactly that color. And see, yeah, then it's coughing up a little bit of extra fuel there. But there's always residual, guys. Always. Maybe the LOX valve closed a bit slower than the main fuel valve. It's possible. It's possible. Pre-valve could have shut too early. Well, they're not pre-valves. The valves could have closed too early. Bear in mind that the copper is just the liner in the engine. Correct. So, yeah, either way, that's cool that an engine is up and running, but a little bit of a change in pace on space news here. I wanted to show you guys this. Take a look at this. Ready? Boop. We're now sitting high and mostly in dry dock. And high and mostly dry in dry dock. Thanks for y'all's support. Oh, look at the Texas, man. Oh, no, not that one. Dude. They moved it from out of San Jacinto. That battleship's over 100 years old, man. Can you believe that? That a dreadnought? It's from the early dreadnought era, MotoKid. Isn't that crazy? USS Texas is the oldest battleship that the US has as a museum by a pretty significant margin, actually. I never knew battleships looked like that under a waterline. It's like a whale. Well, immolated here's the thing. This is what battleships from 100 years ago looked like. That's what the hull of a battleship from 100 years ago looked like. Modern ones don't look like this. The Texas has a really big belt. It's fat right there. It bulges down here. Anybody know why? Any World of Warships player or Navy field player or just person that understands naval combat will know why it bulges down there. Torpedo protection. See this area right here and see how it looks like it's kind of patched on to the side? See that? It looks like it was kind of added to it. That's on purpose. It's a torpedo bulge. That's what a wide belt on a ship does. There's a hollow space in there, so when the torpedo hits it and it explodes, it blows up inside of the hollow space and it doesn't break the ship. That's a torpedo belt. That's what that is. That's why it looks like that. Now, modern ships do have a belt, but they're not built like this. Also, the prow of a ship like this, a prow of like a battleship or an aircraft carrier, doesn't look exactly like this. It looks weirder, believe it or not. Check this out. Like, we'll look, yeah, there you go. I'm trying to find like a picture of the whole thing. There you go. That's what modern ship hulls look like. Well, not battleships, but heavy cruisers, aircraft carriers. Check that out. It's more one fluid shape, right? Freedom Foot of Pittsburgh Steel and Texas, right? I'm not sure. Actually, here, a better picture would be aircraft carrier in dry dock. We'll look at like a modern warship hull. Because a modern warship hull isn't that far off from that thing that you just saw, from the container ship. But here, check out that immolated. Weird, right? But it still has a belt, but the belt isn't as big. Anybody know why? Why would you want a smaller belt? Torpedoes still exist. Why would you want a smaller belt? Anybody know? It's faster? Yeah, you could trade with hydrodynamics. Yeah, sure. Yeah, a smaller belt will make your thing go faster. Smaller belt's a lighter ship and faster. You got it, Chaotic Chicken. You're the one that got it. It is going to make you go faster having a smaller belt like that. Torpedoes don't hit ships anymore, guys. The meta changed. Seriously, the meta changed. Torpedoes blow up underneath ships. They basically, Mike Tyson, they basically depth charge under a ship. They explode, and that rapid expansion of gases pushes the water out of the way because water is incompressible. That creates an air pocket underneath the ship and literally suplexes it. Like if you like wrestling, it'll suplex the ship and it'll break right in half. I want a Ford Raptor. Should you buy one? Yes. Now, Immolated, do you know what this thing's about? So torpedoes RKO ships. Oh, Synard, it is potent. And if you crack a ship like an egg like that, it's not going to be above the water for very long. Immolated, that's what's called a bulbous bow. And the bulbous bow is designed to move the water out of the way so the ship can go through the water faster. Yeah. Weird, huh? Looks like a submarine. What about one from 2012? That means it has a V8 in it, Mank. Yep. See how this water, once again, water's incompressible. If you try to build something that's streamlined, because water's incompressible, hydrodynamics, it'll slow you down. It actually pays because water is so damn incompressible, because it's water, to just kind of pick it up and move it out of the way. And that makes the ship go through the water faster. But yeah, pretty cool, huh? We got about 100 years in ship design meta here. But you can see the resemblance. It's still there in some way, shape, or form. Yeah, if you suplex the ship. You guys want to see that real quick? Yeah, you guys want to see that. This is violent. Like, violent. Watch this. Oh! Oh, that's bad. You see that? It suplexed the frickin' thing. It suplexed that frickin' cruiser. Look at, okay, it cut, right? It definitely cut for the footage is cut up. But I guarantee you, it was literally minutes from that to that. Look at how fast that ship is sinking. Look at how fast it's going down underneath the water. Usually when it's like, okay, take the Titanic for instance, right? The Titanic scraped the iceberg, the watertight compartments didn't work, etc., right? They didn't work, and then it slowly sank over time. Even after the Titanic kind of did the same thing, it suplexed itself. That still took a long time. What this is designed to do is not just break the ship's back, but fill it up with water really, really quickly. It's dude, I'm telling you, it's a suplex. Look. You know how much energy you need to break the ship's back like that? It's a depth charge right underneath it. It puts an air pocket underneath the ship, and the ship collapses on its own structural weight. At least one energy, yep. Look at how fast that thing went into underwater. It's scary. Let's go over here. Yep. It's the same footage. Let's see if they show the whole thing. Nope. They cut the camera. But yeah, that's why you don't run a belt on a modern ship. You don't run a belt, because if a torpedo's underneath you, that's not good. Oh, nice, Chaotic. That's cool. Not, but... Do they design ships to be able to withstand that? It's hard to do that, Mank, because... Long story short, dude... It's hard to design around that because ships don't fly. Yeah. Ships don't fly. Remember, what that torpedo is doing is making a gigantic air pocket underneath the ship. So unless somebody, some naval engineer somewhere, some nautical engineer, designed his ship to fly, Avengers Hellcarrier, no, don't, if the torpedo's coming near you, be somewhere else. What forms of defense do you have against a torpedo? Torpedoes are not very long range because of their propulsion systems, Gorthon. They're not very long range. So that means somebody has to get near you to fire one. Now, don't get me wrong, somebody's going to be like, oh, but EJ, what about this torpedo that can come... Yeah, comparatively to like a cruise missile, it's not very far. There are a bunch of different ways to, like with torpedoes, that you can get them to, like, their propulsion systems aren't very good. They don't make good impulse, to be honest with you. A lot of torpedoes use like hydrogen peroxide, or they could use hypergulls. Oh yeah, you could use that. You could use decomposing hydrazine for a torpedo too, if you really wanted to. Yeah, they use all different ways, all different manner of things to drive the screws on a torpedo. They don't really have good range. They really don't. Comparatively, like, it's not the range of an airplane. You can launch, you can launch a torpedo from, dude, I don't even know. I don't even know what, like, the maximum range for a torpedo is. I know it's not very far. Long story short, don't get people near you. Honestly, we were looking at aircraft carriers. If an enemy ship is close enough to fire a torpedo, that carrier group has failed in its task miserably. Because the U.S. sends out carrier groups with destroyer escorts, guided missile cruisers, and a whole bunch of other fun stuff that you don't want to know. There's other things besides what's on the, what's like on the deck of the carrier. You know what I'm saying? And there's also all the airplanes. An aircraft carrier has a maritime patrol wing on board that was filled via the role of an S-3 Viking, but I forget what they use for it now. A mountain troll, there might be something like that. I don't know what you're talking about. I think SH60s do it, secret code. Yeah, I think that's right. Yeah, long story short, if there's other things, if the carrier has to defend itself, you screwed up. You screwed up royally. I'm seeing around 5 miles average. Yeah, that's not very far, 2020. 5 miles is within is not over the horizon. That means somebody has to get within visual range of you. Yeah, that's why. The carrier group has a lot of other things around it, and the airplanes on the aircraft carrier. Not to mention that they have Tycons going around, so Ticonderoga missile cruisers, and then Arleigh Burkes on the outside of that, and then underway replenishment ships on top of that. Basically, you're not getting near the carrier group to fire a torpedo. It could be a Growler. I think Growlers are they're EF-18s. But I could be wrong. DJ, it had a Chinese sub off the side of the Kitty Hawk in 2006. No one knew it was there. Plane pattern, never saw it. And Bueller, let me ask you this: how many people got chewed out for that? That's what I mean. The submarine. I'm not saying the submarine can't get close. Oh, it can get close. If it gets close, you failed. Somebody probably got reamed. Growler is an EA-18. Yeah, not an EF. That's right. EF didn't sound right. Yeah. The whole idea of the carrier group is to not have that happen. So a lot of people weren't paying attention. I'm sure I was on the flight deck when it happened. Did they just pop up next to you and go, hey, what up? Virginia-class subs are baller? Yeah, I'm more partial to Ohio-class submarines, but... I mean, Benno, they're all cool. But Ohio-class submarines are basically like it's an underwater launch pad that launches SSTOs into space. Plane saw it when landing. I don't think it surfaced. Yikes. Yeah, Unity, right? They could SSTO if they wanted to, Gaw. It's a matter of trajectory if you really want to know. Ever not be able to circularize something in Kerbal because you put your AP too high? ICBMs have a really high apogee. They're basically they shoot them basically straight up in the air. Not basically. They kind of go off on a high ballistic arc, and then they come back down, and the Earth spins underneath, and it comes down on the maximum vertical speed. Yeah, unlike like re-entry. We watched the video about that during break. CLAS for torpedo range and speeds. Okay. Effective firing range was officially greater than 5 miles. Dude, even 24 miles, you'd be able to see that if you have ships spread out in a formation, but yeah, good to know. Google says 40 kilometers nowadays to answer your question. Yeah, okay. There are also limits to a torpedo's maneuverability to have it fit in the tube. Yep. Yep. You tried just listing lazily to the left? Speaking of ships, did you know there's an oil rig museum ship in Galveston? No, but that's really cool. Good tangent about Navy design, guys. That was sweet. Look at the Texas, though, man. Dude, when... You know... I have a question. Does anybody know? And this is not it's not a question like, oh, I know this. But do you guys know that? When was the last time this ship was in dry dock? Can I? When was the last time that thing? About 50 years, 30 years, 2010. Let me see. 2022 dry dock. 1988 to 1990 was the last time it was dry docked. Whoa. Damn, man. When's the last time this ship served? '21st of January 1946, Texas departed San Pedro and steamed via the Panama Canal to Norfolk, where she arrived on the 13th of February and soon began preparations for an activation. On June 18th, she was placed on officially on reserve. On 1947, Battleship Texas Commission was established. Wow. When the battleship was presented to the state of Texas, she was commissioned as the flagship of the Texas Navy. All right, that's pretty cool. Did you know that Texas is an interwar model battleship, top of the line World War I ship? Yep, I did know that, Phone Sister. It's, yeah, Dreadnought era, World War I. Out of service for 65 years. It's crazy. 1948 is when it became a museum. Was anybody here alive in 1948? The Dry Berth Project is what you mentioned earlier. Cool, cool. Not gonna lie, I do kind of wish we had 1 or 2 Iowas in active duty, even if it doesn't make any sense anymore. Are you into tanks? Smoke, not as much as I am with warships and stuff. I like Navy stuff. I think the Navy has the best toys, but I don't hate tanks either. Tanks are really freaking cool. If I could buy a tank, I'd probably, like, you can buy a tank, but if I had the money to buy a tank, I absolutely would. I'm not a prepper, I swear. Queen Mary hasn't had a dry dock period since the 60s. Yikes. I've seen it, Aqualex, the flank maneuver that the carrier does where the deck's leaning. Yeah, I've seen that, dude. Bring back battleships to be platforms for railguns. Well, you could get a Sherp. Wrecker. Sherps are cool. I like Sherps. M113. Those are actually super inexpensive. Yeah, M113s. They made a ton of them. They're like... Yeah, you can buy M113s for like nothing. They're really cool little things. It's just an APC. It doesn't have a gun on it. It's just literally an armored box with treads. World of Warships. Oh gosh. Yeah, Hellfish. I agree with you. The Texas needs a permanent dry dock. Can you imagine walking into a? Can you imagine if they put this thing in like a building and you walked up and you walked into a museum and you saw it like this? World of Warships is pretty fun. World of Warships is toxic. Jeez. Carrier can lean 18 degrees during a quick maneuver. Coyotes, that's absurd. Like, I know the average person is gonna look at that and be like, okay, so what? It's turning. 18 degrees of deck list is unbelievable. That is insane for how big one of those things is. That's ridiculous. Have you played War Thunder before? Yeah, a long time ago though. Saturn V at KSC style. Yep. 100 million would get it a permanent dry dock. Yep. Basically a sailboat. Yeah, real, right? Unbelievable. Texas did a hold my beer to get more elevation out of its main guns to shell things further inland during World War II. Nice. Hey, Jordan. I'm going to be a flight instrumentation technician for GE. Dude, congratulations. You found something. Excellent. Battleship New Jersey was just down there at Texas today. Talked about how keeping them out of the water is actually not good for them. The hull needs water pressure on all sides. Yeah, that's pretty much right, Yard. Yeah, it'll sag. Yeah. Yeah. Ideally freshwater, dude. Saltwater is terrible for it. But also, dry dock is terrible for it as well. Where's the Happy Gilmore jersey, my boy? It's in my house right now, Jordan, but it's, I haven't finished this room yet. It's partially finished. So, yeah. Have you seen Bring a Trailer? You can find tanks on there for sale.
Go
Bring
and
it.
throttle up.
So, Radidex, okay, Radidex, I have a problem. It's a Carcane problem. I know what Bring a Trailer is. I don't go on Bring a Trailer, man. You moved? What did I miss? Oh, yeah, I moved. Yeah, oh, yeah. Fall, that's amazing. I know the Rodney. That's a cool ship. Yeah, one of my favorite British ships, actually. You talked about how the Victory is actually pancaking from being out of the water for so long and not having proper pressure around the hull. Yep. Carcane's a hell of a drug. Oh yeah, Rad, I know. Yeah, Carcane, bad Carcane problem. I own 4 cars. Yeah, that's not good. But I finally bought a house where I can actually put all of them. So, you know, like, that's good. Do you want to do another road trip for a car? Bring a Trailer is how you do that. Yeah. I want to buy more cars, but I have no money. And I don't have a trailer either. I have I'm on an acre of land. I could just buy a trailer. You could buy my old Escort for real. What year is it, Chatter, and how much? I have a truck to tow it with. Why did this not occur to me before? God, I'm stupid. Derpy derp. Not used. Yeah, that's right, Yarn. Yep. Fall, that's amazing, dude. Yeah. You can tow your Fords across the country in a Chevy. And timeout. Yep, I didn't like that. You're gonna stop talking for a little bit. Shatter up, did you see? 98 ZX2 stick black needs a strut tower replaced. $500. Buy a semi, more cars per trip. More cars per trip? I was thinking 500. Shattermage, we've talked about this before, but I have a question. Does this thing look like Kirby if Kirby was an automobile? Yeah, it does. Yeah. See, it looks like Kirby if Kirby was an automobile. Hi. So does that mean it sucks? It looked like Kirby in car form. I'm sorry. Yeah, it's that. Those are cool, to be honest with you. Those are cool cars. Nice, Hibbit. Oh my god, it's Kirby. It's what I'm telling you. It's Kirby in car form. Look, even the interior. Look, it's Kirby in car form. It's been parked for 3 years now. It needs a new strut tower, Shattermage? What happened? How did you break the strut tower? Go get Kirby. Oh, God. Oh, God. Don't do this to me. You rusted out? Oh. Is there any other rust on the car? This is Kirby in airplane form. Nice. It's underneath on the unibody rails. The rockers are toast. Shatter, that's gonna be hard to fix, man. I'll think about it, dude. Seriously, if you're not getting rid of it anytime soon, I'll think about it. I'm serious. I need content for the automotive shop. I'm like, okay, all right. Carcane issue aside, Carcane problems. Just take that, put it over there. That would be great content to fix. It'd be great content for a stream, you know. Carcane Fund. Oh, God. 2020, Hibbit, why are you doing this? Feel free to come visit and look at it. this to me. You're still in the same spot that you're in, right? Copium Car Edition. Shut up, S-Man. Oh, Bino, you didn't know what Bring a Trailer is? Oh, I'm sorry. Yep, Red X, we screwed up. Reddit X, we screwed up. There are people here that don't know what Bring a Trailer is. Oh, no. Oh, no. Oh, no. Car and Bunker Cane. Oh, God. Don't do this to me. Don't do this to me, guys. I gotta finish Fred. We gotta finish the 59. We gotta finish the 59. I gotta do it. Don't do it. Space News. This is supposed to be Space News. This is supposed to be Space News. It's already 10 o'clock. What happened to this stream? Damn it. Oh, God. Space News. Oh, no. Not more bits. Why? Wait. Okay. Yep, that's wrong. Okay. I got through most of these Space News links here. Oh. Here we go. This is something you'll want to see. Chat through you side. Dude, I'm telling you, you got to be careful with that Carcane problem. You start talking about cars and stuff, I won't be able to stop. It's terrible. That's why I don't go on Bring a Trailer, damn it. Here, fellas, Rocket Lab posted this. Check this out, dude. Check this out. This is money. Read that. Yeah, Ponzester, that's fair. How do you think I have it? I'm a freaking auto mechanic. Oh, God. Signer, Jesus. Wait, Signer, how do you think it is? Stop doing that, 2020. Fifth wheel trailer is standard. Both are everywhere. God damn it. Or not, if we buy it, we go to buy it, we'll go big. Core, what's that? Got this? I haven't seen that, no. Can we, let's share that we'll share that for news tomorrow. That's gonna be sick. Oh, I have to get the wheel unpacked. I was supposed to make a freaking rig for that. And Blorgen is... Damn it. Alright, I did that. I got that. I got the Insta stuff. Okay. So what's next race after Monaco? I'm not sure. Nice, Nick Aiden. Alright. Here. So, Rocket Lab successfully test-fired a used Rutherford engine. This one has flown into space and was recovered on a booster. Oh, look at the gimbal. Look at the little gimbal. Look at the little gimbal, the little thrust vector control. It's wiggling. Chad, it's dancing for us.
Ain't gonna fit, won't fit. So the salami lid won't fit. The salami lid ain't gonna fit like that. So the salami lid, and it's the salami lid. The salami lid ain't gonna fit, won't fit. So the salami lid won't fit that. The salami lid ain't gonna fit, won't fit. So the salami lid. Salami leg ain't gon' fit. The salami leg.
I'll stop when I see Freb, okay?
The salami leg ain't gon' fit. The salami leg ain't gon' fit like that. The salami leg ain't gon' fit. The salami leg.
Alright. That's enough. Reused engine, man. Give Fred, please. Oh, Builder, you haven't been here in a while? It's the Salami Lid Won't Fit remix. It's better than its corn. How the heck is that camera not melting? Periscope. Bino. Periscope. Yeah. This one might be far enough away that it's not going to cause any heat. Usually cameras that are like above the rocket don't cause heat. The heat really comes a lot from down here. So this camera could be a good distance away. And yeah, it's looking down at the rocket engine slightly. That should be good enough. But for places where you got to like look at the bottom of the rocket engine or like for a launch pad, it's usually through a periscope. Like, you remember those things, like, you know, you built Fort Kick-Ass as a kid and you try to, like, look out, no girls allowed, like the thing with the two mirrors in it that looks like a Z? That, I'm sorry, your authority is not recognized in Fort Kick-Ass. I'm not playing Railroads Online anymore, Fun Sister. Yeah, something went really weird with the dev team and stuff, and like everyone left except for one dude, so done. No thanks. That's drama. I don't want any part of that. It's a shame. It was a fun game. It had a lot of potential. It has the juice. Dude, look at the thing. Look at the thrust vector controllers. Move that thing around. Isn't that something? Looks like the camera is exposed. It's above the rocket engine, Thomas. It's probably far enough away. Interesting. I learned more here than any studies I've been a part from. Yeah, but you know, this one looks like it's far enough away. But even then, the camera wouldn't be exposed. It'd be inside of like an armored box, and they use It depends. It depends nowadays. They could be using perspex in front of the camera, like just plexiglass or acrylic or whatever. NASA uses quartz lenses. Yeah, they grind the lenses out of quartz. Yeah,
Discovery, go at throttle.
to help with the heat and stuff. The nitrogen purge. Yep. Yeah, we were looking at Astra's engine firing, guys, and we were looking at Rocket Lab's engine. You don't see any green flames or anything from this because it nitrogen purges it. Watch. You'll see it puff out a huge puff of cryogenics. It's not LOX. They puff out liquid nitrogen. Yeah, see? Now that one shot it all over the pad and stuff, but they do shoot it through the engine and stuff. Hey, Hinks. 30-month resub. Yeah, I can't afford that anymore. I was going to say 2020. Don't spend beyond your means, please. Have I seen this? Alright, what do we got? Oh, I'm starting to get tired, man. Damn. Oh, tested to destruction. Okay. Oh, yep, that broke. Yep, that's not working anymore. I do feel a little bit better, Nickhead. Yep. Oh. Yeah, something went very wrong with the mixture on that very quickly. Ooh. So, something went wrong with the mixture there. Could be a failure in plumbing, could be a turbo pump, that could be anything, but remember what I said about green flames? Green flames are fine at ignition, but if you see green flames post ignition like this, yeah, something's gone very wrong. This is basically parts of the engine burning off and being shot out the bottom. Yeah, the engine's basically voiding itself. Yeah, there was an indicator right there. Remember, you can always look at the flames. I'll show you. There it was. See right there? It was only for a second. See what I'm talking about? Something broke in there. there's a flash of green, which means the lining in the engine started melting. You could see that flash just for a second. So this is backwards, forward, forward again. See? It's only showed up in 2 frames, so that was less than a second. Yeah, see? You can see stuff starting to break because the plume goes green for a second and then it goes back and then it goes green for a second and then it goes back again. And then it goes full green. It goes full green and then the engine shuts off. It looks like they may have caught it. The controllers at McGregor may have initiated shutdown. It looks like it stopped. The engine's... I would say that engine's probably not usable, but they did stop it. Yeah, and then there's the purge. They blow the nitrogen through. Watch it again. Remember how I say they got to purge it? And Novaraptor and I were talking about this, viewer in chat. They purge the engine. They blow compressed air out the engine to basically get all the residual propellants out, so that doesn't combust inside. This might be dumb. Copper's used because it conducts heat away from the throat in the chamber thanks to regenerative cooling. Has there been an engine where heat is not conducted away and is instead heat-soaked until shutdown? Ablative nozzles will do that. Never go full green. Yep. Wise words. I mean, Alex, the space shuttle and SLS's SRBs use an ablator nozzle. The nozzle's basically made out of heat shield. You have, dude, basically, guys, if you don't know, like, about thermodynamics, and don't get me wrong, I'm no expert either, heat is quantitative. So, heat is something that you can put in something like, similar, think about it in terms of, like abstractly, if we're thinking about it, like, you could fill a cup with water, you could fill a cup with heat, too, if you want to. It's quantitative. It's just a form of energy. You can fill things with heat. But just like if you pour too much water into a cup, it'll overflow. Right? If you put too much heat into something, it'll melt. The heat has to go somewhere. Shock Diamond seems to extend as well. The engine bored itself out. Yeah, maybe. Yeah. Or they just throttled it down. They do have something like that, Zeno. Yeah, they have an emergency shut off. Yeah, it's the frick button. You have to flip it open and hit it. I've never seen it. I've seen a picture of it. So why not use a heat sink? Back alley, because in terms of heat being put into the rocket engine's nozzle, it would be like trying to catch Niagara Falls with a cup. You're like, oh, I can get all the water. The heat goes. It conducts the heat way too fast. There's too much heat being put in. Is that the video that has a clip of the combustion chamber popping? I'm not 100% sure. That's one Raptor SN144. All right, 2020. Good night. I mean, back alley. There are heat sinks. They use a heat sink is just using ambient air, like a heat sink on a computer, right? It's using ambient air. Basically, if you think about it, a heat sink, like if you look at a heat sink for a processor, right? It's just a bunch of aluminum fins, right? That's more aluminum to fill up, and there's more surface area that's touching ambient air, right? That's all a heat sink is. All you got to do is just maximize your surface area. So that's why a heat sink has these like triangular ridges on it, right? All they're doing is trying to maximize the surface area of the aluminum in the smallest amount of space, and the air goes through those gaps in the aluminum, right? And you have more surface area that's being exposed to ambient air. That's enough to cool down a processor. Processor doesn't flux a lot of heat unless you're rendering something or you're streaming. It moves a lot of heat, right? So You can't do that on a rocket engine for the first reason that I told you. Rocket engines put out way too much heat. It'll just melt the heatsink. However, with that being said, they don't use air as their heatsink. They sink air into the propellant. The propellants going into the engine are extremely cold. So they flow liquid methane through the nozzle, through copper channels. Similar idea, but with liquid. There's copper channels inside of the engine, and they put methane through there. SpaceX puts methane through there before it goes through the pump, then goes through the nozzle, and then goes into a preburner, and then goes into the engine. It basically loops over itself a couple of times. They're using the methane as a heatsink. They're using liquid as a heatsink instead of a heatsink using air. So you're not far off. The other reason why you can't use like a computer heatsink and just put that and put ridges on the outside of the rocket engine is because where rocket engines go, there's no air. Right? It's pretty straightforward stuff. I know, Hibbit. That's crazy, right? And they reset the serial numbers when they started Raptor 2. Yeah, crazy. Does that make sense, dude? Yeah, I mean, you're not far off. Why not use it? They do use a heatsink. They use the propellants as a heatsink. Because the propellants are flowing as fast through the rocket engine's nozzle, through those copper channels. The cold propellant is moving as fast as the gas is being combusted because the propellant leads to the gases eventually. So it flows at almost the same rate. That's how they keep the engines cool. That's how they don't literally melt themselves from the inside out. With the exception of this one. That one melted. Yeah, that one did that. Now, what happened there is for whatever reason it stopped flowing methane. The methane stopped. The mixture ratio went way in favor of the oxidizer. And without the methane flowing correctly in that system, you put too much liquid oxygen and not enough methane, it leans out, the heat has nowhere to go, and it starts eating the rocket engine from the inside out. Yeah, I try, Back Alley. Yeah, that's my thing, dude. Look, I'm an idiot, dude. I have to dumb this down for me to understand it. At least I could do is tell you guys too. Like, I'm stupid. It makes much more sense in my head if you think about it like a heatsink than if I say, oh, well, it uses copper cooling channels that flow liquid methane at a rate of blah, 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 blah. Like, then it's... no, that doesn't work. And pure O2 will make anything burn. It'll make anything burn extremely hot, yes. Mm-hmm, mm-hmm, mm-hmm. Oh! Oh, what? Hey, whoa, hey, oh, nice shooting, Tex. Can you repeat that, but in English now? Bino, plain English, the rocket engine exploded because something didn't go correctly. That one also had a problem right in this area. Right in this area, but, bada boom. Nice, I'm all caught up now. Thanks. I got you, man. I got you. Oh, ho, ho, that's bad. See, okay, for the people that don't know rockets very well, okay? You want a base explanation for how you can tell a rocket engine isn't working correctly? The simplest of the simple. The explosion has to go down. If the explosion's not going down and in one direction, you got a big problem. Now, see, you can see the explosion. It's going down. Everything's working well there. Until it goes up. And that's where you could tell it didn't work. It's not working no more. Nope, that's broken. Yep, no, that's broken. I don't know if they're Booster 7's engines, Aqualux. They might be. Oh, ho, 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 ho. Okay, so this is a horizontal test stand. So the testing criteria has changed a little bit. The explosion needs to go that way. If it goes anywhere but that way, something is broken. And, chat, does the explosion go in a different direction? Oh, yep. This is all in Texas, Red Wagon. Yep, the explosion, see? Up. It went up, so that's broken. I'd love to be in the control room when one lets go like this. Oh, dude, catastrophic depressurization. I think a fuel line came unplugged. If I had to guess, I don't know. To be 100% honest with you, I don't know, but if something pops and it explodes that quick, that fuel line came undone somewhere. What happened here? Oh, yep. I'm flying through the air. That's not good. Excuse me. One hop. Excuse me. Then hop. That looks like a COPV. That's nitrogen. It's a COPV that's storing gaseous nitrogen. And I'm not sure if that was on purpose or not. An important thing to note, guys, just, you know, if you're curious, that COPV did not have a lot of pressure in it, because if it did have a lot of pressure in it, it would shoot off like a bottle rocket. It looks like they were trying to flow a lot of something into it all at once, and not it, but whatever it was attached to popped, because there's a lot of nitrogen that comes out of that line. Yeah, pretty sure that didn't go right either. But, you know, whenever you watch a Falcon 9 or a Starship work, or a static fire test or whatever, guys, this is why SpaceX's stuff, this is part of the reason why. This is a big reason why SpaceX's stuff gets so damn reliable. Like with Falcon 9s, you rarely see a Merlin 1D have a problem. It's because they test Merlin 1Ds on here and push them to their limits, even to this day. SpaceX is testing engines 24/7. That's the reason why they've been able to make the strides that they have. Their testing facility is literally top tier, S tier testing. SMH the environment, keep them. Yeah, jeez. For failure testing, it isn't uncommon to have a designed blowout valve after a test point. That's right, Durango. Yeah, if I had to guess, that looks like that's what that is. That's crazy. Crazy footage, dude. Yeah, a lot of engines just kind of voiding themselves. Test to destruction and learn from experience rather than simply on paper. Yeah, Hunster, that goes to show how SpaceX tests. This is why SpaceX has a lot of fanboys, dude. Because, you know what? Frankly, I think they're right. I never had a problem with SpaceX's testing. And to be honest, I never had a problem with NASA's testing either. But I think NASA could learn a thing or two from, you know, the SpaceX's really super robust testing regime, you know? SpaceX is just put it on the stand and send it, and we'll get a good we'll get a data set based off of that. Hey, Vulcan. Has it been a crazy week for you? Feel like watching some V8s void themselves? I don't know if that's safe for work on stream, you know what I'm saying? Oh, I did want to see this video. I didn't get to see this. This was while I was moving. Yeah, Hunster, but people will see that with SLS. NASA is super transparent about this stuff, especially in the press conferences and stuff. Dude, people are gonna. I guarantee you, this SLS launch will convert a lot of the haters. Maybe not all of them for sure. But, yeah, that's what I wanted to see. Ridiculous. I can't believe that. So, fellas, that was the ship that Blue Origin bought they're scrapping it because they don't want to land at New Glenn on that thing. They're gonna convert a barge, SpaceX style. I did know that, Core. We're gonna get live streams from them if it goes on Saturday. Yep. It's been a nuts week for me. Speaking of which, you want me to DM you a pair of fun photos to show? Sure. That's ridiculous. Bino, there's a launch Saturday. NASA's sending their big rocket. Yeah, dude, there's a launch on Saturday, 2 p.m. 2 p.m. I'll be covering it here. NASA's sending the big boy, the big one. This is the it's called SLS. It's NASA's Space Launch System. SLS is the biggest rocket that NASA has launched since the Saturn V, dude. It's gonna be a pretty red letter day on Saturday. I hope Engine 3 is in a better mood. Chupon, we were listening to the press conference. I started Space News with that press conference. Engine 3 wasn't the problem. It was the DFI sensor, which is not a part of Engine 3. It's an instrumentation sensor for flight data, or not for flight data, for ground testing data from the bleed line, in the context of bleed lines. Yeah, Engine 3 is working just fine. Yeah, it was the DFI sensor on Engine 3, but the DFI sensor is not a part of Engine 3. It's part of SLS technically. Remember when I said it's not the core stage? I mean, it's not Engine 3, it has to be the core stage. There you go. DFI sensor on Engine 3, we'll call that part of the core stage. It's not part of Engine 3. Engine 3 doesn't need that sensor to work. Will it be worthy of the big screen? I think so, Gaw. Okay, thanks for the info. Just got home. Yeah, sure, no problem. They had another presser today where they explained it. They basically proved that it was a bad sensor. Yeah. Engine 3 worked just fine. Actually, all the engines were chilled down correctly. They just couldn't verify that they were chilled down correctly. They're not going to send somebody out to the pad to go and touch Engine 3. You know what I'm saying? Is it still unmanned? This is the first test flight of this rocket, Bino. You generally don't want to put people on the rocket on the first try. Yeah, that's a little dangerous. You're not sure if the rocket's going to work, you know? Don't get me wrong. NASA is not going to launch this thing unless they're pretty dang confident it's going to work, but still, it's not really a smart thing to do. I'll send her, bud. Sign me up. There's no life support on this one, man. Trust me, you don't want to fly on this. Unless you absolutely have to, Vulcan, indeed. Man, that's a big ship. They were going to try to land rockets on that sucker. Shame it never happened. Anyway, I just wanted to see that footage. Vulcan, what are your pictures of? Oh. Yeah. We'll show one of these, dude, if you don't mind. Oh, Discord compressed the hell out of it. But yeah, so Vulcan just sent me this picture, dude. If you want to see, yeah, that's the rocket. The rocket is big. Yeah, that's a big boy. All three are good to show. Yeah. How was remote setup, dude? Oh. So, fellas, check this out. Okay, you see the rocket, right? See right here? That's a staircase. 1 story, 2 story, 3 story, 4 story, 5 story. This thing's freaking gigantic. That's the staircase. See the staircase right there? Look at the railings on the pad. That's a standard kind of like 4-foot railing. Yeah, this thing is not small. Yeah, it's 320 feet tall, a 32-story building. The mobile launcher is even bigger. It's 305 from the top story to the deck, and there's another 50 feet in there. And you know what the crazy thing is? That whole thing fits inside of the VAB. God dang, Vulcan, it's good to... Ugh, what a chunker, dude. I love this thing. This rocket's gonna be so good in the future. Oh my goodness. It's kind of like... How the heck did we figure out how to launch something like that? A lot of time, a lot of number crunching. Yeah. Yeah, a lot of time. It takes a lot of time. Yeah, no, it ain't easy, man. They're launching a skyscraper into space. How many are they making, Euckerman? SLS, there's 4 in the pipeline right now. Well, if you include Artemis 1. So Artemis 1, 2, 3, and 4 are all being manufactured right now. Guys, the big reason why there's such a big distance between Artemis 1 and 2, Artemis 2 isn't until 2024. They're targeting quarter 1, quarter 2 of 2024. The reason why, it's about 18 months. The reason why it's going to take a little while is because they have to get all that data out of this thing. They got to get all the data. They have to make sure that the data was not anomalous when they went to launch. Basically, a sensor can go bad on the way up and screw with your data set. They have to make sure, and you have to verify. You're verifying mountains of data. This is like terabytes of freaking of numbers from the ascent data and the mission data. You got to remember, Orion is targeting a 37-day mission. That's 37 days worth of telemetry. That's a lot of telemetry to sort through. That takes time. A lot of sweat and hard work, indeed. Are these the rockets that land themselves? No, Bino. Basically, this one is not. This one doesn't land itself. This is the orange rocket doesn't land itself. The silver rocket will. That's SpaceX's big boy rocket. This one doesn't land, but it uses all that fuel to move stuff out to the moon. Basically, you know, you can opt to make a fully reusable rocket, right? But if you have a fully reusable rocket, you're going to need to send it up there, refuel it, send up another rocket, refuel it, send up another rocket, refuel it, send up another rocket, refuel it. That's the thing about a reusable rocket. You got to keep refueling it if you're going to send something to the moon. This thing can just send something to the moon in basically one shot. But you expend the vehicle. It's trade-offs. Did I see this? What's that, Captain? I can see the link. I can see the link. I'm pretty sure that's DCS. I'm pretty sure that's DCS, dude. I'm pretty sure that's not real. Yeah. Jeez. Sorry about that. Twitter video just decides to unmute it. Now, you know what the thing is, dude? That footage ain't real. That's a video game. But to be 100% honest, the F-22 could do that. You'd probably break something somewhere, but it can do that. Want to know how I know? Check this out. This is from another Starbase video from the other day. Now, what you're going to see here is not as crazy. It's not as crazy as that. But this is the Raptor demonstration team. They were flying around Starbase the other day. It's not as crazy, but also, oh, he kicked the burners on. You see that puff of smoke come out the back? I just thought it looked cool. All right, dude, get ready for this. Watch. This next one. Right here. So you think that's cool. That's a video game, right? But the thing is that it's pretty dang realistic because the F-22 can actually do stuff like that. Look. I've seen this footage before. It still blows my mind. That's ridiculous. It actually can do that. That's not fake. That actually happened. I know the guy that's controlling the camera. Oh, that plane is nuts, man. It's absolutely nuts. I should have stayed in school. Hey, it doesn't mean you can't enjoy it. Look, look, look. What? What? How? How are you doing that? Oh, that's... Look at the other guy. It's like, all right, I'm going to do it too. I'm good, Alleviate. How are you? Oh, F-22s are amazing. Yeah, Hawks, I know what you mean. Just. Ugh. Captain, isn't that cool? Dude, this is so legit, man. It's so legit. It's so cool. How does it do that? They're copying Starship. I agree. That's nice. It's setting off car alarms. Yep. How to belly flop your fighter plane. Fellas, it's flying backwards. Just thought I'd point it out. It's literally, it's flying like this. It's going backwards, like kind of like that, kind of like down. It's going backwards. It has higher than 1.0 TWR, Ryan. Oh yeah. It depends on the weapons payload though. When it's empty, sure, you can go, yeah, go straight up. Dude. I want one. Yeah, Builder, I know what you mean. Yeah, Dead Scum, it can do that. Does it mean that it can attack things behind it by doing a J-turn? Yeah, Mank, you could do that, but what's called a Cobra is Cobra is what you could do with the F-22. If you don't J-turn, you do J-turn, but you kind of J-turn up like this, and you basically vector the plane up to get the angle of attack up towards 90 degrees, and you basically turn the entire plane into a huge speed brake, and then you kind of come back down and you're behind somebody. Yeah, it's called a Cobra. It's called a Pugichev's Cobra. Yeah, yeah, it can do that. F-22s fly over your house multiple times a day, every day. They still leave me amazed. They're such a beautiful plane, Sticks, yeah. And then there's another thing that you can do to kind of J-turn it, I guess. You can Cobra, and then in a Cobra maneuver with the thrust vectoring, if you yaw to the right, the plane will it'll kind of spin around like this, like a leaf almost. So it's spinning on the yaw axis. So doing this, kind of boomeranging almost. You can, I forget what that maneuver is called. It's something leaf or whatever. Yeah, if you Cobra into a leaf like that, you can literally turn the plane around in a matter of seconds. It really kind of depends on how much you Cobra and how much you slow it down. But yeah, the plane can turn around. It won't like be able to turn around and go right back. You can Cobra, and then you can flip the plane around, and then if you hit the burners, it'll start going in another direction. It's called a falling leaf. Yeah. If you watch the new Top Gun, that. You know the part. I'm not going to spoil anything. Yeah, Builder. Mm-hmm. Yeah, so that 5th generation fighter that they call in the movie, that's an Su-57. It can do that. Oh yeah, Su-57s can do that. Sure. Heck, its predecessor could do that, an Su-35. Oh yeah, you can do the falling leaf. Oh yeah. Mm-hmm. Yeah, they get those. The F-22 can do it, but they can actually do that. Yeah, that it's pretty crazy. That's why I kind of like. That's why I like that movie, you know. Because that, yeah, no, it seems like, oh, that's fake. That planes can't do. Oh, yes, it can. Nice, Jonathan. There you go. Nikkei, this is the new office, but the new office isn't finished. It looks cool, but it's not really practical. Yeah, I mean, honestly, well, like, from what now don't get me wrong, I'm not a fighter pilot, I'm not even a pilot. But from what I understand, if you get into a dogfight, these planes can do it, but if you got into a dogfight, something really went wrong. With an Su-57 or an F-22. Yeah, if you get into a dogfight with these things, something went wrong. Alright, Builder. Yeah, okay. Anyway, Vulcan, great pictures. Talking about fighter jets and stuff. Guys, yeah, that's enough. I gotta get up in the morning. We have Blue Origin launching in the morning. So launch weather forecast for SLS is currently 60% probability to go, which is a pretty dang high probability. That's good. But anyway, yeah, I'm gonna call it for the night. I was gonna play more F1 Manager, but we'll get the next race maybe tomorrow or something. Can't use these maneuvers in dogfights because they bleed too much energy. Yeah, I mean, you could do that pinwheeling thing, right, Durango? And you're basically a sitting duck. If a missile will go right through your canopy. It's a new Shepard launch yard, and it's scrubbed 2 times. But yeah. It's actually really screwing me up, dude, because what I've been trying to do is get up early. So, like, it's not a matter of waking up for me. Like, I've been trying to get up early, and I've been trying to finish my damn office. 9:30 for Blue Origin, for New Shepard, yeah. Yeah, there you go, Wednesday. Yeah, exactly. NS-23, yep. Will it be crewed, or is it just experiments? It's just experiments, from what I understand. Another great stream. Thanks, Orion. I'm glad you guys like it, man. You know, we kind of went off a little bit on talking about other things, you know, for space news today, but it's fun. I had fun. 9:30 Eastern smoked, yeah. Here, I'll double check just to be sure, because they do move it around. Here, let me take a look-see. $9:30 a.m. Central, so it's 10:30 Eastern tomorrow, fellas. 10:30. What was that thing you wanted to talk about? Oh, Jackal, I asked you the other day if you'd gotten more seat time since we talked. Racing, have you raced at all since? If you're streaming it, I'll be there. Yeah, Smoked, I'll be here, dude. 10:30 Eastern. Damn, yeah, mank, saucy mank person. Yeah, it's a bit of a story, I guess, though. Oh. Alright, we can talk about it some other time, dude. All good.